Yeah, hi everyone, welcome back. So now we are going to study about two-dimensional random variable. So previously we used to have only one random variable x or random variable y. But now what if both of the random variables are coming together? Then what will happen? That we are going to see. But before that there are some prerequisites that we have already seen in the previous video. The integral calculus we have seen and conditional probability we have seen. So I hope you have watched that previous video as well, because that is very important. I will be taking reference of the previous video again and again in this particular lecture. Okay, so that mathematical part was very important. Let's get started with the two-dimensional random variable. So let's just say I am given only one random variable x. If only one random variable x is given, so I can define its CDF, cumulative distribution function. So I can define the CDF in this manner, fx of x. What does it say? It says that probability of random variable x taking values lesser than equals to small x. And I can define its PDF as well, which is shown by this, and that is equals to simply the differentiation of CDF, right? If you differentiate the CDF, what you will get? PDF. And there was another relation. What was the relation? That fx of x is given by this, d by dx goes here. From here you would get this particular thing, right? Do you agree to this point? But here if you are putting the limit in terms of x, then here you should put another variable. That variable we were putting as q. Similar thing you can do with the random variable y as well. What would be its CDF? CDF would be that random variable probability of random variable y taking values lesser than equals to small y. What would be its CDF? What would be its PDF? PDF will simply be differentiation of CDF. And from here, what is the relation between CDF and PDF again? So CDF would be given as running integration. This is known as running integration from minus infinity to y of the PDF given. So yes or no, right? Now what if I am taking both of the random variables together into action? So for that we will define joint CDF of random variable x and y. Here what I was saying, CDF of random variable x, CDF of random variable x. What this was? CDF of random variable y. Now what I will define? Joint CDF of random variable x and y. What does that mean? How I will define it? I will define it in this manner. X comma y. This is how I will define it. fxy x comma y. Here also somewhere in some textbook you will find that here also comma is given. So it is just a way of representation. This is just a way of representation. What does this joint CDF represent? So this joint CDF represent probability of random variable x taking values lesser than small x and probability of random variable x taking values lesser than equals to small x and probability of random variable y taking values lesser than equals to small y. Is that clear to you or not? There is and, okay, and if there is this and, so 99% of the times this and will be represented by comma. So in whole communication system, wherever you see comma means and or intersection. Wherever you see comma means intersection. Are you able to understand this point? So let's understand it more by example. Let's just say I have written fxy 2 3. What is the meaning of this? So x is related with 2 and y is related with 3. So probability of random variable x taking values lesser than equals to 2 and probability of random variable y taking values lesser than equals to 3. This is the meaning of fxy x comma y. fxy x comma y. So this is known as joint CDF of random variable x and y. Is that clear to you? Now here when we used to differentiate the CDF, what we used to get? PDF. So here also we will define joint PDF as well. Joint PDF of random variable x and y. If we have defined the joint CDF, we can define the joint PDF as well, right? And how we will define it? Here what we used to do? We used to differentiate with respect to x. We used to get the PDF of y. So here also we are having the joint CDF. What we need to do? We need to differentiate it. But now we will differentiate it we will partially differentiate it with respect to x as well and with respect to y as well. Do you know what is the meaning of partial differentiation? Let's just say I have given you a function x square y. Now you differentiate it, you partially differentiate it with respect to x and with respect to y as well. Basically, partially differentiation with respect to x, partially differentiation with respect to y. So you need to do these two things. So what you will do? First, you will differentiate with respect to x, keeping y as constant. So keeping y as constant, differentiation with respect to x, that would be 2x. Now you will differentiate with respect to y, keeping x as constant. So 2x is a constant value, differentiation of y will be 1. So final answer will be 2x. So basically, partial differentiation means if you are differentiating with respect to y, that means only y will be variable, rest all constant. And if you are differentiating with respect to x, then only x will be variable, rest all constant. Okay, very simple meaning. So what you will do is that you will partially differentiate the CDF, with respect to x as well, with respect to y as well, because this is the function of random variable x as well, this is the function of random variable y as well. So in both of, with respect to both of them, you will partially differentiate and you will get your joint PDF. Okay, don't get too much afraid of these like what do we call it, these notations. These notations are not the matter of concern. Problem solving is the matter of concern, right? So we will solve a lot of questions, like I will solve 8 to 10 questions here. So you will be very comfortable with this particular topic, because two-dimensional random variable is one of the, it is considered as one of the toughest topic of whole communication system, not only for random variable, for of whole communication system, but we will deal it in the best possible manner. Okay, so have some patience and just keep on seeing the notation. It is very easy to write down fx of y, x comma y, probability of random variable x taking value lesser than equals to x, probability of random variable y taking value lesser than equals to y. In between there is a comma, that means it is end. And then if I differentiate with respect to x with respect to x and y, then what I will get? I will get my PDF. Now from here, if I need to get fxy, what I need to do? So here, if differentiation used to go here, what it would become? Integration. If differentiation goes here, it would become integration, right? So here as well, if this differentiation goes here, what it would become? It would become integration as well. It would also become integration of this particular thing. Limit will go from where to where? Here limit we would use to go from minus infinity to x, but here the limit will go from minus infinity to x, along with that minus infinity to y as well, right? Limit of x will also go, limit of y will also go. Here if you are putting the limit in terms of x, if you are putting the limit in terms of y, so here you cannot put xy. So what you will do? You will put pq here. Okay, what you are going to put? You are going to put pq. So don't get afraid of these notations. Everything will come to you. Everything will be crystal clear. Okay, so just have some patience. What you need to do, you are just integrating with respect to x as well and with respect to y as well. Then you will get your CDF. Very simple thing. Just we are interrelating with one-dimensional random variable with the two-dimensional random variable. Is that clear to you? This slide is clear to you? Not tough at all, right? So we will move slowly only, okay? Because this particular topic is kind of typical for a lot of students, but we will move slowly. Let's go to the next slide. Now let's see the properties of joint CDF. So what is the meaning of this? fxy x comma infinity. So probability of random variable x taking values lesser than equals to x, comma, probability of random variable y taking value lesser than equals to infinity. Now just let me know, isn't it certain that 100% it is sure that the random variable y will take value lesser than infinity only? Isn't it certain? Yes, surely sir, it is certain. That means now what will be our matter of concern? Our matter of concern is only x now. So can I write it down with this, in this manner? Say yes or no. So this is your fx of x. If this particular thing is given, from here how would you get fx of x? So in place of y, what you will put? Infinity. That's it. If I put in place of y, if I put infinity, what it is saying? Probability of random variable y taking value lesser than infinity, which is sure, no, which is 100% sure. You are 100% sure that y will be taking value lesser than infinity only. So that means this is not our matter of concern now. Our only matter of concern is this particular thing. And what does this particular thing represent? CDF of random variable x. So this is actually known as marginal CDF of random variable x. Marginal CDF of random variable x. Is that clear to you? We will solve the problems, but as of now, is this property clear to you? Right? You understood that surely your random variable y will take values lesser than equals to infinity only. What about this one? What this will be equivalent to? Think about it. Probability of random variable x taking value lesser than equals to infinity, and probability of random variable y taking value lesser than equals to small y. So this is 100% sure. No? 100% it is certain that x will take the value lesser than equals to infinity only. It cannot take value greater than infinity. So this is not our matter of concern. So what is our matter of concern now? Only this is our matter of concern. So this can be represented as fy of y, because I know that probability of y taking value lesser than equals to y is known as fy of y only. So this is known as marginal CDF of random variable, marginal CDF of random variable y. Is that clear to you? Very, very important properties. Okay, usually people mug it up, they don't understand it, but we are understanding as well. How did we understand? You understood, right? Because x is not a matter of concern here, y is not a matter of concern, only matter of concern is x, only matter of concern is y. Well and good. What do you think, what will be the answer of this one? Fx of infinity. Probability of random variable x taking value lesser than equals to infinity, probability of random variable y value taking value lesser than equals to infinity. What that would be? It is 100% sure that random variable x will take value lesser than infinity only. Also, it is 100% sure that random variable y will also take value lesser than equals to infinity only, because it cannot take value greater than infinity. What does that mean? That means this is a certain event, probability will be 1. Say yes or no. So fxy infinity would be 1. You don't need to mug up anything, right? You will think there. What is the meaning? Okay, x probability of random variable x taking value lesser than equals to infinity, and probability of random variable y taking value lesser than equals to infinity. What does that mean? That means it is a certain event. Surely they will take value lesser than equals to infinity only. That means probability will be 1. What about the other one? What about this one? What does it say? Probability of random variable x taking value lesser than equals to infinity, and probability of random variable y value taking lesser than equals to minus infinity. What does this show? And so let me know, I am telling you a statement, let me know if this statement is possible or not. Let's take the value of sorry, here x is written, no? Let's take this x value is 2. So I am saying that probability, find the probability such that your random variable x is taking value lesser than equals to 2, and your random variable y is taking value lesser than equals to minus infinity. What I am saying, find the probability such that your random variable x is taking value lesser than equals to 2, and your random variable y is taking value lesser than equals to minus infinity. Is this event possible? And there is in between and. That means you need to satisfy this condition as well, and you need to satisfy this condition as well. Can you ever satisfy this condition? No. Random variable y can never take value lesser than minus infinity. That means if you are not able to satisfy this condition, that means you are not able to satisfy the whole probability. So what will be the answer? 0. The point is y can never take value lesser than equals to minus infinity. If in place of minus infinity, if any number was there, let's just say 3 number was, let's just say in place of minus infinity 3 was there. So I would have said that I need to find the probability such that x is taking value lesser than 2 and y is taking value lesser than 3, which is possible. But y can never take value lesser than minus infinity. Right? If it cannot take value lesser than minus infinity, that means this particular probability will be 0. Are you able to understand this point? Okay. So we are not going to mug up anything. We are going to understand every single thing with respect to very basic formula. Just it feels like it is aptitude, right? Forget about communication, forget about engineering, forget about mathematics. It is just simple aptitude. Just treat yourself as a class 10th student and you are studying aptitude only. Okay. So this is simply aptitude. What do you think? What will be the answer of this one? Probability of random variable x taking value lesser than equals to minus infinity, not possible, right? This is possible, but this is not possible. In between there is and. Since this is not possible and one thing is possible, that means you cannot satisfy both of the condition. So what will be the answer? 0. Answer would be 0. And here both of the conditions cannot be satisfied. X also cannot take value lesser than minus infinity, y also cannot take value lesser than minus infinity. So what will be the answer? 0. Is that clear to you? All good? All fine? So if one of them is minus infinity, your job is done, answer would be 0 only. Okay? If both of them are infinity, then answer would be 1. If one of them is infinity, then you need to think, okay, y is not our matter of concern, only x is left. Here x is not a matter of concern, only y is left. So this will be the marginal CDF, this would be the marginal CDF phi. So nothing we are mugging up, we are just understanding it by the basic concept. So this particular slide is very, very important. More points we are going to see. Again, CDF is a non-decreasing function. Look, CDF, fx of x was non-decreasing function. This was a CDF, right? This was also a CDF only. And this is also a CDF. So whatever the property they used to follow, the same property this will also follow. That means it is non-decreasing function. So if x2 is greater than x1 and y2 is greater than y1, that means your fxy x2 y2 would be greater than or equals to fxy x1 y1. Say yes or no? Because it is a non-decreasing function, no? So if x2 is larger, then joint CDF with respect to x2 will also be larger. If y2 is larger, then joint CDF with respect to y2 will also be larger. If x1 is lower, then joint CDF with respect to x1 and joint CDF with respect to y1 will also be lower. There you go. Right? Very simple. Very, very simple. And value will be between 0 to 1 because this was also CDF, this was also CDF, this was also CDF. So value was always between 0 to 1. Value will always be between 0 to 1 only because what they represent? They represent the probability. Although they represent the probability in a range, but surely they represent the probability only, no? And probability is always between 0 to 1 only. So they are always associated with respect to probability, and probability is always between 0 to 1. So this point is also clear. Now here I will write down a formula. Probability of a rectangle. What do I mean by that? What you need to find? Look, previously what we used to find? We used to find probability such that your random variable x is taking value between x1 to x2. Let's write down it as a, b, c, d. It will be more easy for you. Okay, let's not call y1, y2. A, b, c, d. So what we used to find? Probability of random variable x taking value between a to b, right? So on the upper limit, I needed the equal sign. On the downward limit, I don't need the equal sign. So yeah, this is the desirable condition. So answer would be fx of b minus fx of a. This was the answer, right? And we remembered it. So here also I will write down the answer. You try remembering it if you can. I will tell you very simple method you will be able to remember. But for solving the problem, we will see the concept. Look, we will solve this question with respect to formula as well, with respect to concept as well. So as of now, I am writing down the formula. And I will tell you how to remember this particular formula as well. And then we will solve a question. First we will solve with respect to concept and then we will solve with respect to formula. So how will you write down the formula? And why it is known as probability of rectangle? So just think about it. Here what is happening? Your x is between a to b. Your x is between a to b. X is between a to b. This axis is x and this axis is y. So x is between a to b and y is between c to d. Y is between c to d. So this is the range of x, right? Between a to b and y is between c to d. So let's just say this is c, this is d. So y is between c to d. C to d. So this would be the range of y. So what is the common region? This is the common region, no? Are you able to understand this point? This is the common region, right? So isn't it like the probability of a rectangle? What would be this point? You can write down these points, whatever these points are there. Forget about it. So isn't it like a rectangle? So that's why it is known as probability of a rectangle. Okay. So what is the formula? fxy, take the higher limit, bd plus fxy, take the lower limits, ac minus lower limit from here, higher limit from here. AD minus higher limit from here, lower limit from here. So basically higher limit plus lower limit plus lower limit, higher limit minus higher limit, lower limit minus. And this is the desirable condition, no? That here you need the equal sign, here you don't need the equal sign, here you need the equal sign, here you don't need the equal sign. So you can put plus plus here as well. You can put plus plus here as well. And if you don't want to put plus, then mostly this particular option will not be mentioned. Which option will be mentioned? The option that will be mentioned will be without the plus sign, right? The option that they will mention in the examination, that would be without the plus sign. Because you know that B plus is equals to B only, A plus D plus is equals to D only. So it is very rare that this formula will be used to solve the problem. But what may happen is that they can simply frame an option that which of the statement is true. They will write down probability of random variable x taking value. Okay, really sorry guys, here it should be capital X, no? Find the probability of random variable x taking value between A to B. So this should be capital X. So let's write down in a correct manner. Probability such that random variable x is taking value between A to B and random variable y is taking value between C to D, right? So what will be the formula of this particular thing? So in the option they will mention this particular thing. So you need to click on this particular formula. Okay. So there you cannot derive it. Now we will see the concept that how this formula came, and you will be able to realize that without using this formula as well, we can solve the problem. Well and good. So is that clear why it is known as probability of a rectangle, and how do you write down the formula? Higher limit, lower limit, lower, higher, lower. That's it. Lower limit, higher limit will be coming with plus sign. Lower limit will be coming with plus sign. Lower, higher will be coming with negative sign. Higher, lower will be coming with a negative sign. All good? All fine? Okay then. Let's see this question. Let's understand the question now. So first let's understand the question. X and Y are two random variables such that X is taking values 0, 1, 2. So what it is? Discrete random variable. And this is also discrete random variable. Both are discrete random variable, right? X is taking value 0, 1, 2, Y is taking value 1, 2, 3. Their joint PMF is defined. The way we define joint PDF, in the same manner joint PMF can also be defined. What is the meaning of PMF? What was your Px of X? That was probability of random variable x taking value small x. What would have been your Py of y? Probability of random variable y taking value small y. What would have been your Pxy x comma y? So probability of random variable x taking value small x, probability of random variable y taking value small y. That's it. This is how you can define the PMF as well. So this kind of table you will see a lot of time in information theory. In digital communication as well, this kind of table will be there. So you should know what is the meaning of this table. So this tells the joint PMF of random variable x and y. So what do you think? What is the meaning of this 0.15? This says that probability such that random variable x is taking value 0. This 0.15, this is coming with respect to x equals to 0 and y equals to 1 is equals to 0.15. So probability is such that random variable x is taking value 0 and random variable y is taking value 1 is equals to 0.15. I am just telling you what is the meaning of this table. We are not solving the problem. Now what do you think? What is the answer of this thing? Probability of random variable taking value x equals to 1 and y equals to 3. X equals to 1 and y equals to 3, that means this is 0.17, right? X equals to 1 in this line and y equals to 3, which is this particular thing, right? What if I ask you probability of random variable x taking value 3? Can the x take value 3? No, there you go, answer is 0, right? Y can take the value 2, but comma means and. So x cannot take value 3, that means answer is 0. Are you able to understand this point, right? Now what they are asking, you need to find the probability such that your x should be taking value between 0 to 2, excluding 0, including 2. That means x can take value 1 and 2. So yes or no? They are asking the probability of x taking value 1 and 2 and 1 or 2 and y taking value between 1 to 3, excluding 1, including 3. That means it can take 2 or 3. Is that clear to you? What they are asking probability of random variable x taking value between 0 to 2, but 0 cannot be included. That means it can take value 1 and 2, 1 and 2, 1 or 2 actually, not 1 and 2, 1 or 2 I should write down, 1 or 2, and y can take value 2 or 3, because y can take value between 1 to 3, including the 3, so 2 or 3 it can take, right? So between what they have written 1 to 3, 1 to 3. So this could be equals to, let's just say random variable x is taking value 1 and random variable y is taking value 2. Will that be acceptable? Surely it will be acceptable, right? Random variable x is taking value, random variable, what they are saying, random variable is x is taking value 1 and y is taking value 2. Random variable x is taking value 1, y is taking value 2, plus random variable x is taking value 2 and y is also taking value 2. Basically what I will do is that 1, 2, 1, 3, 2, 2, 2, 3. All these cases I will take. Basically what I mean to say is that if random variable x is taking value 1, y can take value 2, y can take value 3 as well. So first case we wrote down, random variable x is taking value 1 and y is taking value 2. Or what could be the case? That your random variable x is taking value 1 only, but y is taking the value 3. Or what could be the case? That your random variable x is taking value 2 and y is taking the value 2 as well. X is taking value 2, y is taking value 2. Or what could be the case? That your random variable x is taking value 2 and y is taking value 3. X is taking value 2 and y is taking value 3. So these 4 cases would be there. Now let me know what is the probability of x equals to 1 and y equals to 2. X equals to 1 and y equals to 2, 0.03. 0.03 plus. Next what we need to find, x equals to 1 and y equals to 3. So x is taking 1 and y is taking 3. So that would be 0.17 plus x is taking 2, y is taking 2, 0.25 plus x is taking 2, y is taking 3, 0.1. Right? So what is the answer? 0.55. 0.2, 0.45, 0.55. This is the answer. Right? So by this table as well you could solve this problem, no? That what did you understand from here? That your x can take value 1, 2, x can take value 2, 3. That means y cannot take value 1, x cannot take value 0. This is the condition. So x cannot take value 0, that means all these will not come. And y cannot take value 1, that means this will not come. So only these will come. Are you able to understand this problem? With respect to diagram only. With respect to diagram, what we are saying is that from this particular probability, what do you understand? That x can take value 1, 2, y can take value 2, 3. So this can be taken, this can be taken, this can be taken, this can be taken. That means what is common between these guys? These are common. So addition of all of them will be the answer. Now let's solve it with respect to the formula that we have written. What does the formula say? This is written, formula will say fxy 2, 3 higher limit plus lower limit 0, 1 minus lower higher 0, 3 minus higher lower 2, 1. So let's find out the value of this particular thing. Here we will write down the answers, but let's find out the value of fxy 2, 3. What does it say? That probability of random variable x taking value lesser than equals to 2 and y lesser than equals to 3. Right? This is the meaning. x taking value lesser than equals to 2, y taking value lesser than equals to 3. Isn't it certain? What do you think, what will be the probability? Probability will be 1, because what they are saying, random variable x should take value lesser than equals to 2 and y should take value lesser than equals to 3, which is certain, no? That means all these cases will come, and when you add all these cases, 1 will come. You can see that 0.15 plus 0.05 plus 0.1, what it would be? 0.3, 0.4, 0.6, 0.9 and 1. That means what they are saying, random variable x should be taking value lesser than equals to 2 and y should be taking value lesser than equals to 3. That means all the cases would come. X taking value lesser than equals to 2, y should be taking value lesser than equals to 3. So this particular thing would be 1. What about this particular thing? fxy 0, 1. Probability of random variable x taking value lesser than equals to 0 and y taking value lesser than equals to 1. What do you think, what will be the answer? X should be lesser than equals to 0 and y should be lesser than equals to 1. That means x can be 0 and y can be 1. That's the only case. Just think about it. Think about it with respect to aptitude. That x should be lesser than equals to 0 and y should be lesser than equals to 1. So only two cases, only this case is there, no? That means this probability will come into action, 0.15. Are you able to understand this point? What about fxy 0.3? Probability of random variable x taking value lesser than equals to 0, y taking value lesser than equals to 3. X taking value lesser than equals to 0 and y taking value lesser than equals to 3. That means all the values of y will come, but only value of x will come, that will be x equals to 0. That means you can take x equals to 0, y equals to 1, x equals to 0, y equals to 2, x equals to 0 and y equals to 3. That means all these will come into action. Are you able to understand this point? X equals to 0, y should be less than, x should be less than equals to 3, x should be less than equals to 0. What does that mean? That means x can be 0 only, because less than 0 is not possible. So only x can be equals to 0. Now y should be less than equals to 3. That means y could be 1, 2, 3. So x equals to 0, y equals to 1, x equals to 0, y equals to 2, x equals to 0, y equals to 3. So all these will come into action. So what will be the answer? 0.3. And what do you think, what will be the answer of this particular thing? 2, 1. Probability of x taking value lesser than equals to 2, but y should be lesser than equals to 1. So what do you think, what should be the answer? X should be less than equals to 2, x should be less than equals to 2, but y should be less than equals to 1. X should be less than equals to 2. That means everything would come 0, 1, 2. So this would also come, this would also come, this would also come. But y should be less than equals to 1. That means y cannot be less than 1. So y has to be equals to 1. So only this condition will come. Right? So x equals to 0, y equals to 1, x equals to 1, y equals to 1, x equals to 2, y equals to 1. So you add all of them. What you will be getting? 0.3. So 2, 3, this was 1, 0, 1, this was 0.15, minus 0.3, minus 0.3. So what you are getting? Minus 0.6, that would be 0.4, and answer is coming out to be 0.55. So I just wanted to prove the formula, nothing else. In the examination, you are not going to do this particular analysis, right? In the examination, you will just think, okay, what this is saying? 0 to 2 excluding the 0, that means 1, 2 I can take. 1, 2, 3 excluding 1, that means 2, 3 I can take. So 1, 2 here, 2, 3 here. So 1, 2 is possible, or 1, 3 is possible, or 2, 2 is possible, or 2, 3 is possible. So I will add all of them. My answer will be 0.55. That's it. But you should know how to utilize this formula as well, because in the examination what may happen is that they will just write down this particular line and they will ask you whether this line is true or not, or they can frame this line in the options and they can ask you if this particular line is true or not, right? So this formula should be there in your mind. Higher limit, lower limit, lower limit, lower, higher, higher, lower. With higher, higher, lower, lower, plus sign would come. With higher, lower, lower, higher, negative sign would come. That's it. So this formula should be there in your mind. It may come directly in the examination, but it is very rare chance that you will be using this formula to solve a particular problem. The problem will be solved on your own. Now in this question only, what if someone asks you probability of x equals to 0? Find the probability of x equals to 0. In this question only I am asking probability of x equals to 0. What do you think? What will be the answer? So just think about it. If x is equals to 0, y could be 1, or if x is equals to 0, y could be 2, or if x is equals to 0, y could be 3. That's it. So if you need to find the probability of x equals to 0, then that means you just need to add this line. That's it. Can you compare this table? Just compare this table with A and B. Let's just say this is A1 written, this is A2, this is A3, this is B1, this is B2, this is B3. What this will show? A1 intersection B1. Say yes or no. Probability of x taking value equals to 0 and probability of y taking value equals to 1. Probability of x taking value 0 and means this is comma, but actually it is intersection. So isn't it like A1 intersection B1? And isn't it like A1 intersection B2? And isn't it like A1 intersection B3? Now if I ask you what is the probability of A1, do you remember? What do you remember? The conditional probability. There I made this kind of thing, that let's just say there are 3 events, B1, B2 and B3. In all of the event, A1 is common. So what is the probability of A1? Let's make the diagram in a good manner so that you will be able to relate. Okay. Communication is nothing but simple mathematics. All important part is that you should be able to relate it, nothing else. If you are able to relate, your job is done. Right? This is how subject should be studied. Just we need to relate the things. So let's just say this event A is A1 and this is B1, B2, B3. If I ask you probability of event A1, what that would be? A1 intersection B1 plus A2 intersection B2 plus A3 intersection B3. We are doing the same thing here. If I ask you probability of x taking value 0, probability of random variable x taking value 0, 0.15 plus 0.05 plus 0.01 plus 0.1, so 0.15 plus 0.05 plus 0.1. What is the answer you will get? 0.3. Randomly, if I ask you what is the probability of taking y equals to 2, what do you think? What will be the answer? Y equals to 2. That means if y equals to 2 is coming, then x could be 0, or it could be 1, or it could be 2. Basically, if I am saying that y is equals to 2, so x could be 0, taking y equals to 2 only. X could be 1, taking y equals to 2 only. Or x could be 2, taking y equals to 2 only. So what will be the answer? Just you add this line. So this line is showing probability of y equals to 2. This line is showing probability of y equals to 1. This line is showing probability of y equals to 3. This particular line is showing probability of x equals to 0. This particular line is showing probability of x equals to 1. And this particular line is showing probability of x equals to 2. And addition of all these probabilities should be equals to 1. Because this is only is happening. If x can take value 0, then y can take value 1. Or x is taking value 0, y taking value 2. Or x is taking value 0, y taking value 3. Or x is taking value 1, y is taking value 1. Or x is taking value 1, y is taking value 2. Or x is taking value 1, y is taking value 3. Or x is taking value 2, y is taking value 1. Or x is taking value 2, y is taking value 2. Or x is taking value 2 and y is taking value 3. Addition of all of them would be 1. And you can check, I have framed the problem in this manner only, that addition of all of them is 1 only. So now are you able to understand the meaning of two-dimensional random variable? This was a discrete random variable example. We will see the example with respect to continuous random variable as well. So are you able to understand the basic meaning now? Right? So if I ask you probability of y taking value equals to 2, so 0.05 plus 0.03 plus 0.25. So 0.05 plus 0.03 plus 0.25. Right? I have put the same thing now. 0.05, 0.03, so 0.8, 0.33, right? So this is the answer. All good, right? Yeah. So we will see these kind of examples again and again. Don't worry about that. क्या हो गया भाई? Just slide should be changed. Array. Just 1 second, guys. Yeah. So we have solved this question. This question is clear to you, right? So first this was asked, then we verified the formula as well. This is method 2. This was method 1. Just we wanted to verify the formula, and then we understood about this particular table as well. From this table, everything we can determine, right? So we will see more problems regarding this particular concept only, but let's move to different kind of problem, or let's see the properties of a joint PDF now. We have seen the properties of joint CDF. We have solved one question as well. Let's see the property of a joint PDF. So what was your joint PDF? So when you partially differentiated your CDF with respect to random variable, with respect to x as well and with respect to y as well, what did you get? You get your joint CDF. Okay. If you differentiate your joint CDF with respect to x and y, you will get your joint PDF. Now you need to find the marginal PDF of x. What do you need to find? Marginal PDF of x. That means what you need to find? Fx of x. Right? So what someone will say that, sir, first I will find the marginal CDF of x. What someone will say that, sir, first I will find marginal CDF of x and then I will differentiate it. What is this? Marginal CDF of x. Say yes or no. You can think like this. And how you can find marginal CDF of x? Sir, marginal CDF of x is very easy, sir. What I will do is that I will just kill y. I am just making certain that y should take value lesser than equals to infinity, which is certain. So from here I can find the marginal CDF of x as well. So sir, I have find the marginal CDF of x and then I will differentiate it. I will get the marginal PDF of x. So if CDF is mentioned, then I can follow this particular method. But what if PDF is mentioned? What if this joint PDF is mentioned? From here, how can you get fx of x? What I am saying, joint CDF of random variable x and y is mentioned, and from here you need to get the marginal CDF. How will you get it? This is my question. So just let me know one thing. This will be a function of x only, no? This will be a function of x, right? Function of x. Now let's just say your fxy is a function of x and y both. Now you let me know, I will differentiate this particular thing with respect to y and I put the limit of y, let's just say from 1 to 3. So x will be a constant, right? What will be the answer you will be getting? Let's take the limit from 0 to 3. Okay, I am taking the limit from 0 to 3. So what is the answer you are getting? 9x by 2. So this was the function of both x and y, but you differentiated with respect to y and you put the limit of y. So that means y got killed, right? In the final answer, your y is not there. Y has been made a constant value. So similar thing you need to do here. What you need to do? You need to find fx of x, right? This could be a function of both x and y. This could be a function of both x and y. So what you will do is that you will differentiate it with respect to y from minus infinity to infinity, or whatever the limit is given. Let's just say y is going from 2 to 3. Your random variable y can take value from 2 to 3 only. So you will put the limit from 2 to 3. Your random variable y can take value from 2 to infinity. So you will put here 2 to infinity. Are you able to understand this point? What I am saying? This could be a function of both x and y. But in the final answer, you only need function of x. So what you are actually doing is that you are integrating it with respect to y, and you are putting the limit of y from minus infinity to infinity. You are putting the constant limit of y. So your final answer will come in terms of x only. Are you able to understand this point? So two ways are there. If marginal CDF is mentioned, if marginal CDF is mentioned, if marginal CDF is mentioned, what you will do is that from there, sorry, not marginal CDF, really sorry guys, this is your joint CDF, really sorry. If joint CDF is mentioned, if joint CDF is mentioned, what you will do? You will find the marginal CDF, you will find the marginal CDF, and from here you will differentiate, you will get the marginal PDF of x. Now what if marginal, what if your joint PDF is mentioned? So from joint PDF, directly how will you get a marginal PDF? Directly how will you get marginal PDF of x? So what you will do, this could be a function of both x and y. I'm not saying that always it will be a function of x and y. It could be constant as well. But what you need to do, you just need to pick this one and put the limit of y. That means what I am doing, I am putting limit from minus infinity to infinity. That means now I am killing y. Y is being totally integrated. Only x is left. So this will be a marginal PDF of random variable x. Are you able to understand this point or not? Okay. Usually all these things are understood with respect to very complex mathematics, but we are not going into the complex part of mathematics. By the simple intuition we are understanding what is happening here. These are purely intuition, right? No mathematics I am using. Directly we are able to write down the formula. Just think about it. If a joint CDF is given, I can find the marginal CDF and from there I can get the PDF. If joint PDF is given, that means this is telling about x and y both. But if I need to get the marginal PDF of x, that means I need to care about only x. So what I will do, I will integrate with respect to y, putting the complete limit of y. Because if I put the limit of y, then what will happen is that the final function will be in the terms of x only. And this is what I want. Is that clear to you? It will be very easy to remember and very easy to understand as well. And we will solve the problems, it will be more clear to you. Okay. So with patience, you keep on watching whatever that we are dealing here. And similarly, you can find the marginal PDF of y as well. So what would be your marginal PDF of y? Marginal PDF of y. That would be fy of y. So someone will say that, sir, what I will do is that I will differentiate this particular thing. And how will you get this particular thing? That, sir, if fxy is mentioned, I will kill x. That means it is 100% sure that x would be taking value lesser than equals to infinity only. So from here I can get my fy of y, and then here I can put it. What I can do, here I can put it, and from here I will get marginal PDF of y. But what if joint PDF is mentioned? If joint PDF is mentioned, what I will do? Sir, here fxy x comma y is telling that both x and y are into action. But what I will do is that I will differentiate with respect to x, and I will put the limit of x from minus infinity to infinity, or whatever the limit is there. Let's just say x can go from 0 to 3, so I will put the limit from 0 to 3 only. If x can go from 1 to 5, then I will put the limit from 1 to 5 only. So now what will happen is that this will be integrated with respect to x, so x will be made a constant, and only this will be a function of y. Is that clear to you? So from here I will get my fy of y as well. So these two concepts again very important, and very easily we have understood this kind of concept here. Say yes or no. Right? Very easily we have understood this concept. Well and good. Let's go to the next property. So your fx of x was also a PDF, fy of y was also a PDF, and fxy x comma y was also a PDF, right? This was also PDF, this was also PDF, and this was also PDF. So all the properties of PDF, they will follow that it will be non-negative. You know that PDF will always be positive and area under the curve will be 1. So area under the curve, and here area under the curve will be taken as x going from minus infinity to infinity and y going from minus infinity to infinity. Because previously what was happening, only x was there or only y was there, but now x and y both limit would be there. So area under the curve will be 1. X going from minus infinity to infinity, y going from minus infinity to infinity. Area under the curve will be 1, right? Or here I should better write region R. Whatever the region this x and y are making, in that region R, your complete area would be equals to 1. Okay, so surface integration would be equals to 1. Are you able to understand this point? Whatever the region your random variable x and y are making, in that particular region, your surface area would be equals to 1. And here you already know that whatever the limit y is taking, in the whole limit, your area under the curve would be 1. Here also area under the curve would be 1, right? Now there is something called independent random variable. Okay, So if A and B were independent events, A and B are independent events, independent events. So what was happening? Probability of A intersection B was equals to PA dot PB. So isn't it like intersection only? So that would be equals to fx of x dot fy of y. I am just interrelating, nothing else. Fx of x, fy of y. So in the question, if it is given that x and y are independent random variable, so you can do this kind of thing. Independent random variable. If x and y are independent random variable, then joint CDF of random variable x and y would be, joint PDF of random variable x and y would be equals to marginal CDF of random variable x multiplied with marginal PDF of random variable y. What I am saying, joint PDF slash CDF of random variable x and y would be equals to what? Marginal PDF or CDF of random variable x and y multiply with not x and y, are only x, because this is x, this is y, multiplied with marginal PDF or CDF of random variable y. There you go. So don't feel like that, sir, there is a lot of things to remember. Just you keep on looking at it, you will be able to utilize it with respect to questions as well. With respect to the problems, you will be able to realize it. Okay, so we will solve a lot of problems and everything will be remembered. So don't feel like that, sir, there are a lot of things to remember, sir, I might forget it. Nothing like that. You are not going to forget anything. Okay, so here for interrelating, what did we write? If A and B are independent events, probability of A intersection B was equals to probability of A dot probability of B. Right? All good? All fine? So let's revise whatever that we have studied till now. So not too much, just we are revising it. Random variable x was given. You can find CDF of random variable x. You can find CDF of random variable y. When you partially differentiate it, what do you get? PDF of x, PDF of y. Right? Then joint CDF is defined. What is the meaning of joint CDF? That means here it will take x and y both into action together. Both are into action together. That means x taking value lesser than equals to x, y taking value lesser than equals to y. Right? From here you can get that. If you partially differentiate it with respect to x and y, you will get your joint PDF of random variable x and y. And if you integrate your joint CDF, if you integrate your joint PDF, then you will get your joint CDF. Now these are the properties which we have already seen. Then this formula of probability of rectangle, this formula we see, we just saw that we need to remember it. Otherwise, with respect to concept as well, you can solve it. Then we saw the properties of joint PDF, that partially differentiation of joint CDF will be your PDF. Now this was very important. How would you get a marginal PDF of random variable x and marginal PDF of random variable y? So how will you get it? Fx of x, fx of y I need. So if my joint CDF is given, what I will do? In place of y, I will put infinity. Because in place of y, if I put infinity, I can get my marginal CDF of x. And if I differentiate my marginal CDF of f, if I differentiate my marginal CDF of x, what I will get? I will get my marginal PDF of x. And what if joint PDF of random variable x and y is given? If joint PDF of random variable x and y is given, and I need to find the marginal PDF of x, what I will do? I will integrate with respect to y, and I will put the limit of y. If I do so, what will happen is that there will not be any term of y, only term of x will be left, and that will be equals to marginal PDF of random variable x. And same thing I can do with respect to marginal PDF of random variable y as well, right? It will be non-negative, because PDF are non-negative. PDF will always be greater than 0, and area under the curve will always be equals to 1. So here this was curve, but this will be a surface. So area under the surface will be equals to 1, because here limit of x will also go, limit of y will also go. So area under the surface would be equals to 1. So surface integration would be equals to 1. Here this simple integration was equals to 1. Here surface integration would be equals to 1. And if x and y are independent random variable, then what will happen is that fx of y, x comma y would be equals to fx of x dot fy of y, and CDF of random variable x and y would be equals to marginal CDF of random variable x into marginal CDF of random variable y. Well and good, crystal clear. Now we can solve the problems. So one question, then second question. So a lot of question we are going to see. In between we will see a small concept, then again more questions. So we will keep on solving the problems now. Okay. So just revise whatever that we have studied in this 1 hour, and then let's start solving the problem. So don't try it on your own. If you want to try it, you can try it, but just think about it. How will we get the value of b? So let me pause the video, take some break. I will drink some water, and then I will come back and we will start solving this particular question. Okay. Yeah, welcome back. So we need to find the value of b here, and then this is the second question. You need to find the probability such that x plus y is less than 1, and then we need to find the probability such that x plus y is equals to 1. So this is a 2-dimensional random variable. You can see this is the joint PDF is given. It will be mentioned in the question. Okay, joint PDF of random variable x and y is given. So let's compare it with the 1-dimensional random variable. What I am doing, I am just comparing. Let's just say my fx of x is given as that it is e to the power minus x for x greater than or equals to 0, and it is otherwise 0. And let's put b here, b e to the power minus x. So what we used to do, what we can do is that we can make the graph of fx of x versus x. So I know that random variable x is taking value from 0 to infinity. It is taking value from 0 to infinity, and with respect to that we are having this particular graph. The graph is like before this it was 0, then at x equals to 0 the value is 1, and at infinity it will again come down to 0. So this is the graph. So what we were drawing? We were drawing x versus fx of x. Our random variable x is taking value from 0 to infinity, and this is our fx of x, which is at x equals to 0 the value is b, right? Similarly here, what is the scenario? Here there are 3 things. There is random variable x, there is random variable y, and then there is fxy, x comma y. Here what was the scenario? Only 2 things were there, x and fx of x. Now here there are 3 things, x, y, or let's call this as y, x, y, and fxy, xy. Basically x is there, y is there, and fxy, xy is there. So here what they are saying, x is taking value from 0 to 2. So x is taking value from 0 to 2. This is the line of x. So this is the range of x, right? This is the range of x. Here x was taking value from 0 to infinity. Here this is the range of x. X is taking value from 0 to 2. And y is taking value from 0 to infinity. Y is taking value from 0 to infinity. So that means what is our matter of concern? What is our region of operation? Our region of operation is this much. X is taking value from 0 to 2, y is taking value from 0 to infinity. So this is our region of operation. This is our region of operation. Say yes or no. This is our region of operation. Do you agree to this point? So usually in 1-dimensional random variable, I can make x versus fx of x. But now in this region, you need to make fxy, xy, which is equals to b e to the power minus x plus y. So making this graph is not possible, no? Are you able to understand this point? Like making this particular graph here, it is depending on x as well, it is depending on y as well. So we will not make this graph. Are you able to understand this point? Basically, we will not show the y-axis. Not y-axis, I should say, we will not show the vertical axis. Here this was the horizontal axis, that x was taking value from 0 to infinity, and on the vertical axis, I was showing the value of your PDF. Now, this is my horizontal plane. On the horizontal plane, what I am saying, value of x is from 0 to 2 and value of y is from 0 to infinity. On the vertical axis, here I am supposed to show the value of joint PDF. I am supposed to show the value of joint PDF. but that I'm not gonna show because making the graph will be difficult here. So why do we need to make the graph? No, I don't need to make the graph. Let's just say here I need to find the value of b. Do I need to make the graph? No. What I need to do? X is taking value from 0 to infinity. X is taking value from 0 to infinity. b e to the power minus x dot dx should be equals to 1. This is my job, right? Because I know that, what do I know? Minus infinity to infinity, fx of x dot dx will throw 1. So what I will do? From 0 to infinity, b e to the power minus x dx. Why 0 to infinity? Because x is taking value from 0 to infinity only. So b e to the power minus x dot dx should be equals to 1. So here, do I need this particular graph? No. What I need, I only need that x should be going from 0 to infinity. That's it. This is what I need. So x is going from 0 to infinity. So I integrated it. What I will get? B equals to 1 I will get. Is that clear to you? So here what I will do? Here I will only see what x is taking. This is how I will make the axis, x and y. I don't care about fxy. Fxy would be somewhere here towards me. This particular plane is here. The horizontal plane that you see, that I have made like this. So I only care about x and y. X is taking value from 0 to 2. X is taking value from 0 to 2. And y is taking value from 0 to infinity. That means what will be our matter of concern? Our matter of concern would be this particular surface. Our matter of concern will be this particular surface. What I need to find? I need to find the value of b. Here what we used to do? We used to integrate. But here we will double integrate because x is also varying, y is also varying. Then what we used to write down? We used to write down our PDF. And then we used to integrate the whole axis. We used to integrate the whole axis from 0 to infinity, right? With respect to x. From minus infinity to infinity. Although it is non-zero from 0 to infinity, that's why we just put 0 to infinity here. So what we used to do? The limit of x on the whole axis. The limit of x on the whole axis. But now, in the two-dimensional random variable, this axis have been changed to a plane. So now what I need to do? I need to integrate it over the plane. I need to integrate this particular thing over the plane, or you can say region R, and that would be equals to 1. So now are you able to understand this particular thing? Just compare it with one-dimensional random variable. In one-dimensional random variable, we used to make x versus fx of x, or you can say fx of x versus x. But drawing this particular diagram will be difficult. So in two-dimensional random variable, we will only care about x and y, and we will just see the surface. Okay, this is the surface. So in this particular surface, my surface integration should throw the value equals to 1. That's it. So here also I can choose the strip. I can choose the vertical strip. If I choose the vertical strip, what will happen? So in the vertical strip, you can see that value of y will be going from, value of y is going from 0 to infinity, and value of x is going from 0 to 2. So value of y is going from 0 to infinity, and value of x is going from 0 to 2, and this is given. I am just telling you the core concept, that how we are solving the problem like this. Otherwise, I could have directly said that, okay, just make the area and then integrate. This is how it is taught. But how do you compare two-dimensional random variable with one-dimensional random variable? Here also, if it was possible, we could have drawn the graph as well. Surely drawing the graph is possible. ChatGPT can draw the graph for you, but you cannot draw the graph, no. So I am not caring about the graph. Even here as well, I don't need to care about the graph. Only thing I care is how much value my random variable x is taking. So here also I am caring about only one thing, that how much value my random variable x and how much value my random variable y is taking. So x is taking from 0 to 2 and y is taking from 0 to infinity. There you go. Dot dx dy is equals to 1. So I can solve it, right? Surely I can solve it. So what I should do is that let's keep this on the second page, okay, and let's keep it here. So I will solve it. How will I solve it? You can differentiate, like constant limit are there, no? Constant limit are there. So you can integrate with respect to x, you can integrate with respect to y. Differently you can integrate, right? Because constant limits are there. So first I will integrate with respect to x, with respect to x. So b is already a constant, e to the power minus x dot dx. And then I will integrate with respect to y, e to the power minus y dot dy should be equals to 1. So this integration will be 1 only, and what will be this integration? E to the power minus x, 0 to 2, there would be negative sign. This integration will throw 1 only, right? So b into 1 minus e to the power minus 2. If you put e to the power minus 2 and e to the power 0 would be 1, there is a negative sign. So what will happen? 1 minus e to the power minus 2 should be equals to 1. So from here, b value is coming out to be 1 upon 1 minus e to the power minus 2. This is the answer. Okay. So this is the answer of b. Did you understand this point? Okay. Let's see the next question now. What your next question is saying. What they are saying? They are asking you to calculate probability of x plus y should be less than 1. What they are asking? Probability of x plus y should be less than 1. This is what they are asking. Let's again compare. In this question, if I had asked you probability of x less than 1, what you would have done? Where is x equals to 1? This is your x equals to 1. So what you would have done is that x less than 1. What you would have done? You would go here, and you would say that, sir, whatever my PDF is there, I will integrate it less than 1. That means minus infinity to 1. Value of x should be less than 1. That means I will integrate my PDF from minus infinity to 1. Do I need to care about the graph? I only care about the expression. I don't care about the graph. I need the expression of fx of x. Are you able to understand this point? I need the expression of fx of x, but whatever the graph is there, I don't care about that. Now I know that graph will be starting from 0. So 0 to 1. What is the value of graph? b to the power minus x dot dx, and then I can solve it. I will get my answer. What is the probability of a random variable x taking value lesser than 1? So what I would do? I would just integrate it. I would just calculate the area. Here what is the scenario? Here random variable x is there. Here random variable y is there. Along with that, another condition, x plus y less than 1. So on this particular plane, here what you are making? You are making the line of x equals to 1. Right? And then you know that my matter of concern is x less than 1. What is my matter of concern? My matter of concern is x less than 1. Then you would know that this area would come into action. X less than 1. This area would come into action. So similar thing you will do here. What you will do? X plus y less than 1. That means now you will make the line of x plus y. How you will make the line of x plus y? Can you make the line of x plus y? Yes. X plus y equals to 1. That will be this line. X plus y equals to 1. That will be this line. So this line is x plus y equals to 1. X plus y less than 1 you need. That means if you put 0, 0, that means this region will come into action. So now your matter of concern will be this particular region. Your matter of concern will be this particular region. Let's just say this region I am calling as R. I will surely make this region in 2D as well, but just try thinking about it. Now in this particular region R, what you will do? In this particular region R, what I will do? I will take my joint PDF and I will just integrate it. This is what we are doing here as well. You are taking your PDF and you are integrating in the region which is matter of concern. What is the matter of concern? From minus infinity to 1. But you get to know that x is greater than 0. So matter of concern will be from 0 to 1. So what you are doing? You are taking your PDF and then you are integrating from 0 to 1. What is your matter of concern? So now what is my matter of concern? My matter of concern is this particular region. So now I will integrate my PDF in this particular region. So let's make it in a better manner in 2D. So in 2D, what did you get to know now? That already what was given? Already given was that x is from 0 to 2 and y is from 0 to infinity. This was already given. Already given that x is from 0 to 2. That y is completely there from 0 to infinity and x is there from 0 to 2. X is there from 0 to 2. This is already given. I don't need to care about the lower side. Why I don't need to care about the lower side? Because I know that y is from 0 to infinity. Y is from 0 to infinity. So this was already given that your matter of concern is this particular region. This is your matter of concern. Now what they are asking, in this particular region as well, what you need to calculate? You need to calculate such that x plus y is less than 1. X plus y is less than 1. So can you draw the line of x plus y equals to 1? Surely I can draw the line of x plus y equals to 1, which is this one. this line is x plus y equals to 1. So x plus y less than 1. X plus y less than 1 will be this region, right? X plus y less than 1 will be this particular region. So in this particular region, x plus y less than 1. How will you calculate x plus y less than 1? You will put 0, 0 here. 0, 0 is less than 1. Yes. 0 plus 0 will be equals to 0 only. 0 plus 0 will be equals to 0. So 0 is less than 1. Yes. That means this particular region will come into action. So now this is my matter of concern. So in this region R, I will take my PDF and I will integrate it. That's it. This would be my answer. Now, do you know how to integrate? Surely you know, right? You surely know how to integrate. So what you will do? In the region R, what you will do is that you will take the strip. You will take the strip. And since this line is x plus y equals to 1, so what will be this point? And what will be this point? This point will be x equals to 0, y equals to 1. And this point will be x equals to 1, y equals to 0. You have taken a vertical strip. So value of y is going from 0 to 1 minus x. So your integration will go from, you know that value of y will go from 0 to 1 minus x. And if you move the strip, x will go from 0 to 1. X will go from 0 to 1. Here what is given? fxy is given, that is b e to the power minus x, b e to the power minus x plus y, dx dy. And this is something that I need to calculate now, right? So I know the value of b. So what I can do is that x is going from 0 to 1, y is going from 1 minus x. Value of b was 1 upon 1 minus e to the power minus 2, e to the power minus x, e to the power minus y, dx dy. I told you one thing, always we will first integrate with respect to y, because this is the variable limit. So what I will do is that 1 upon 1 minus e to the power minus 2 outside, x is going from 0 to 1, x is going from 0 to 1, e to the power minus x dx, and when you integrate e to the power minus y, that would be e to the power minus y divided by minus sign would come, and limit will go from 0 to 1 minus x. So what I can do, I can take the limit from 1 minus x to 0. Did you understand what I did here? I know that when I solve this particular integration, e to the power minus y, just one second guys. Yeah, so what I was saying, so e to the power minus y integration will throw e to the power minus y and then negative sign. So to adjust that negative sign, what I am doing, I am interchanging the limit 1 minus x to 0, right? Because I don't want to use the negative sign. If I use the negative sign here, that means the limit will go from 0 to 1 minus x. Limit will go from 0 to 1 minus x. Now if I kill that negative sign, that means I can interchange the limit. Well and good, very simple mathematics, nothing else. One minus e to the power x minus 1 dot dx, right? E to the power minus x, e to the power 0, 1 minus e to the power x minus 1. X going from 0 to 1. So 1 upon 1 minus e to the power minus 2. X going from 0 to 1. E to the power minus x minus e to the power minus 1 dot dx. Okay. So when you integrate, what you are getting? E to the power minus x, and then there will be a negative sign, minus e to the power minus 1 x 0 to 1. Is that clear to you? Right? If I integrate e to the power minus x, what I will get? E to the power minus x minus sign, and minus e to the power minus 1 is there. So e to the power minus 1 dot dx, that will throw x 0 to 1. Well and good. So what I can do is that I can take out the negative sign, so this will become plus, and then I can interchange the limit. It goes from 1 to 0. So just I interchange the limit, nothing else. So what you are getting, e to the power 0 would be 1 minus e to the power minus 1. Here you will put, here also you will put. So this would become 2 e to the power minus 1. So this is the answer you are getting, 1 minus 2 e to the power minus 1 divided by 1 minus e to the power minus 2. This is the final answer that we are getting. Is that clear to you? Okay. The important part was understanding till this particular point. Once you have understood this particular point, then whatever that we have done in the last lecture, the same process we are following here, the surface integration. But are you able to relate your one dimensional random variable with two dimensional random variable? In one dimensional random variable as well, we were doing the same thing. Whatever that we are doing in the two dimensional random variable, the same thing we were doing in one dimensional random variable as well. Again, there we used to make the graph, but fx of x, the graph was not matter of concern. Only matter of concern was the expression. And the second matter of concern was how the value of x is going. So x is going from 0 to infinity, I would take the expression and then dot dx. Similarly here as well, x is going from 0 to 1, sorry, x is going from 0 to 2 and y is going from 0 to infinity. I will take the expression, I will integrate the complete surface and I will equate it to 1. So if I equate it to 1, I am getting the value of b. Very easily I am getting the value of b, right? Then next what I need to do, next x plus y less than 1 they are asking me to calculate. So here as well, in this particular scenario as well, x less than 1, how would I calculate? I will take the limit of x from minus infinity to 1 and then I will take my PDF and I will integrate it. So here as well, I will take my PDF, I will integrate it, but now what is the limit? X plus y less than 1. That means now this is a surface. So I need to do the surface integration. That's it. I did the surface integration. I got the answer. Might be some calculation error. I don't think there is any calculation error. Just to check it. Just check it once. I don't think there is some any calculation error, but the concept is clear to you, right? The concept is crystal clear. This is considered as one of the most complex topic of a random variable, which we are understanding in a very good manner. Why it is complex? Because people don't relate it with one dimension random variable. They directly study two dimension random variable, forgetting about one dimension random variable. So actually, one dimension random variable and two dimension random variable both are the same thing only. There is no difference. In one dimension random variable, you just need to do one integration, but here you need to do the surface integration. That's it. This is the only difference. If I introduce three dimension random variable, then what I will have to do? I will have to take a volume integration, right? If I am introducing three dimension random variable, let's just say I define random variable x as well, y as well and z as well, and with respect to that I define joint CDF, sorry, joint PDF, that is this. So now I will have to make four axes actually, x, y and z, and with respect to that I will have to make fx, y, z as well. Although three dimension random variable, till this point they never asked the question on three dimension random variable. Okay, only they asked question on one dimension random variable and two dimension random variable, because three dimension random variable will be very tough. So they don't ask question on that, right? But are you able to understand whether it is one dimension, two dimension, three dimension or n dimension random variable? Analysis is same. You take your PDF, you integrate it. In one dimensional, it will be simple integration. In two dimension, it will become surface integration. In three dimension, it will become volume integration. Are you able to understand this point? Are you able to relate the things now? So in communication, where we mug up the things, now instead of mugging it up, we are actually understanding the concept, right? Now, what do you think? What will be the answer of this one? X plus y equals to 1. What do you think? 0. Because what you are doing? You are doing the surface integration. Surface integration of a particular line, what that would be? That would be 0 only, no? If I ask you how much area this line is enclosing, 0 area. Line doesn't have any area. 1 line, 2 line, 3 line, 4 line, yeah, this is having any area. But what will be the area of this line? 0 only, no? And just think about it, probability of x equals to 1. In case of continuous, what is this? Continuous random variable. In case of continuous random variable, when there was only one dimension random variable, what was the probability of x equals to 1? 0. So in case of two dimension random variable, what will be the probability of x plus y equals to 1? That would be equals to 0. So here you need some region. What you need? You need some area. you need some area like this, so that you can calculate the line integration. Sorry, not line integration, so that you can calculate the surface integration. You need some area here. But in x plus y equals to 1, you will not get any area. That means answer will be simply equals to 0. And just think about it, no, what they are saying, x plus y equals to 1. That means x is taking a certain value and y is taking a certain value. If I say x is equals to, let's just say 1, because x can take value from 0 to 2. So what will be y? Y will also be certain, that would be equals to 1. But in this condition, x plus y less than 1, x plus y less than 1. If I say that my x is 0.5, so y could be 0.1, y could be 0.2, y could be 0.3, y could be 0.2222. So y has a lot of chances. That means y will have some range. X will also have some range. But here both of the values are fixed. If x value is fixed, then y value is also fixed. That means you are talking about probability at a point. And probability at a point will always be 0 in case of continuous random variable. So this is nothing but a probability at a point only, right? So this will be 0. Is that clear to you? Conceptually as well it is clear. This is a simple line, it should be 0. It is a simple point, it should be 0. So conceptually and mathematically, in both of the cases, you know that this region will not be there. This region R will be simply a line. So instead of surface, this is simply a line. If this is simply a line, that means this particular surface integration will throw the value 0 only. Clear? Let's go to the next question now. Okay. Joint CDF of a random variable x and y is given. You need to find these answers. The answer I have given, that is 0.1. For which particular question the answer is given? I guess for this particular question I have given the answer. So what you need to find? You need to find probability of random variable x taking value from 2 to 3, and joint CDF is given. What they have given? Joint CDF. What you need to find? First one. This is question A, this is question B. So question A. That means you need to find fx of 3 minus fx of 2. This is what you need to find. That means what do you need? I need fx of x. What do I need? I need fx of x. This is my requirement now. To solve this particular question, what do I need? Fx of x. That means what is given? Joint CDF is given. What I need? Marginal CDF. Can I find it? Surely I can find it. How will I find it? Fx of x is equals to fxy x comma infinity. So in place of y, what I need to put? Infinity. What I can do is that fxy, in place of x you put x only, but in place of y what do you put? Infinity. So you will get your fx of x. So in this particular expression, in place of y if I put infinity, here, yeah, now someone will say that, sir, here y greater than equals to 0, here y less than equals to 0. So y equals to infinity should be put here, no? Sir, you are saying that I need to put y equals to infinity. So y equals to infinity will lie in this range. Here they did not even talk about y. So if they are not talking about y, then by default you need to consider that this will work for y going from minus infinity to infinity. Are you able to understand this point? If y is not mentioned here, so by default you need to take that it will be going from y equals to minus infinity to plus infinity. That means here as well you will put y equals to infinity, here as well you will put y equals to infinity. So if you put y equals to infinity here, what will happen? This will become 0. So 5x divided by 4x plus 1. 5x divided by 4x plus 1. And this will be 0 only. When the limit of x goes from, because now I care about only x, limit of x goes from 0 to 4. What I am finding? I am finding fx of x. For finding fx of x, what I need to do? In place of y, I need to put infinity. Here I put infinity. Someone will have a doubt, sir, y equals to infinity should be put here. But if nothing is mentioned, that means by default you need to take that x is going from 0 to 4. If x is going from 0 to 4, then this is the expression. Then if they are not mentioning about y, that means if y goes from minus infinity to infinity, then this would be the expression. But if x is less than 0 and y is less than 0, then this would be the expression. If x is greater than 4 and y is greater than 0, then this would be the expression. Are you able to understand this point? When x is between 0 to 4 and y could be anything, then this would be the expression. When x is less than 0 and y is less than 0, then this would be the expression. When x is greater than equals to 4 and y is greater than equals to 0, then this would be the expression. Is that clear to you? Now here, this 0, basically this CDF is 0 for x less than 0 and y less than 0. So CDF is 0 for x less than 0. That means if you make the graph of fx of x, so it would be 0 for x less than 0. For 0 to 4 it will follow this particular graph. For 0 to 4 it will follow this particular graph, and after 4 it will follow this particular graph. If you put y equals to infinity here, so this will be 0, this will be 0, so it would be 1. So if I try making the graph, of fx of x, so it will go somewhat like this. Before that it will be 0. For x less than 0 it will be always 0. Between 0 to 4 it will follow this curvature, and after 4 it will become 1, which is pretty obvious, right? Because I know that fx of infinity should be 1 and fx of minus infinity should be 0. Now how this curve will go, that I cannot tell. I need to differentiate and all these kind of things I need to do. So at 0 what value it is throwing? It is throwing value 0 only. At 1 what value it is throwing? 5 by 8. At 2 what value it is throwing? 10 by 12. So let's make in this manner. However the graph can go, it can never be decreasing, that I know. So from 0 to 4 this is how it is going. The nature here is, this is your fx of x versus x. So this nature is 5x divided by 4x plus 1, and this nature is 1 and this is 0. So this is your graph of fx of x. But what do you need? You need the probability 2 to 3. Fx of 3 minus fx of 2. So 3 and 2 both will be lying here, right? So if you put 3 here, what you are getting? 15 divided by 16, right? If you put 2 here, what you are getting? 10 divided by 12. So 15 divided by 16 minus 10 divided by 12. I can do the calculation with the calculator. Zero point 104. So this was the answer. Well and good. Okay. Now second question, between 2 to 3, 1 to 4. What do you think? I will have to apply the formula here, right? Without the formula I cannot solve this problem, because otherwise it will become very difficult. I will just have to apply the formula. Fxy is given, and which formula I am talking about? The formula that I told you to remember. Which formula I told you to remember? You understood the previous question, no? You understood the previous question for sure, right? What I needed fx of x. How will I get? Putting value of y equals to infinity. So here I put the value of y equals to infinity, here I put the value y equals to infinity. If I put y equals to infinity, here I am getting 5x divided by 4x plus 1, and here if I put y equals to infinity, I am getting 1. So this kind of expression I am getting, this is my fx of x. Okay. Now this is something that I require. So for this what I will do? I will apply the formula only. 3 4 plus 2 1 minus lower limit higher limit 2 4 minus 3 1. Now putting these values will be very difficult. Value of x is 3, value of y is 4. X is 3, y is 4. So x is 3, it will lie here, y 4 will lie here. So this particular condition will be coming. So x equals to 3 and y equals to 4. You put a very complex expression will come, no? Right? So let's try putting. So 5 by 4 x equals to 3 and y equals to 4. Right? This is what they are expecting me to write, 3 and 4. 5 by 4, 3 plus 4 to the power 3, 64. 3 plus this will become 3 plus e to the power minus 64 divided by 3 plus 1, that would be 4, minus e to the power minus y square. So value of y is 4 only. So e to the power minus 16. So this is the answer of, separately let's write down, okay, let's write down separately. So this was the answer of fxy 3 4, right? Now fxy 2 1. So value of x is 2, value of y is 1. So again you will lie in this region only. Value of x is 2, y is 1. So again you will lie in this region only. So 2 divided by 3, 2 plus 1 is 3, and 9, 27. So 5 by 4, 2 divided by here 1, I am putting, no, 1, e to the power minus 1. Now this will create problem, e to the power minus 1. Here it was 1 only. So e to the power minus 3, e to the power minus 3. This would be e to the power minus 3. So did you understand the point? You can solve the problem now. X equals to 2, y equals to 4. X equals to 2, y equals to 4. Again in this region you will lie. And then x equals to 3, y equals to 1. X equals to 3, y equals to 1. Again you will lie in this region. Right? So always you will lie in this region. You will write down the values, you will get the answer. So you can solve it. There will be long calculation. Although it will not come in the examination, I am just telling that who knows, sometimes you need to use this formula as well. So that's why it is just a revision that you should be remembering this formula. Otherwise the calculation will be long. A calculation will be long enough. You can do the calculation on your own if you want to do. Okay. So long calculation will be there. I should have framed the question in a better manner, such that calculation would be lesser. But now here the calculation is becoming longer. So I don't think I need to calculate it. You can just put the values and you will get the answer. How will you put the values? That is important. The value of x is lying in this region, value of y is lying in this region. What if x was lesser than 1? Sorry, what if x was minus 2 and what if y was minus 2? Then here answer would be 0, right? Probability would have been 0. This particular thing would have been 0. If let's just say here minus 1, minus 3 was written, that means x is less than 0, y is also less than 0. That means you would lie in this region. So that would be 0 only. Okay. But this is what they are not asking. They are asking 3 4 2 1 2 4 3 1. So you will get the answer in this manner. You can solve it. Let's go to the next question. Yeah, let's go to the next question. So before going on to the next question, we need to study conditional PDF. What do you think? What is conditional PDF? Do you remember the conditional probability? Probability of A by B. Probability of getting A such that B has already occurred. That was PA intersection B divided by PB. So this is just the notation. What is the notation? PDF of random variable x such that y has already taken some value, x by y. So don't be afraid of the notation. Okay, don't be afraid of the notation. Just understand what they are saying. A intersection B, no, A intersection B. That means you need to consider x and y together. I need to consider x and y together. That means you need to write down the joint PDF of x and y divided by probability of B, probability of B. That means in downward what will come? Marginal PDF of y. What I am saying, x by y, x divided by y, that would be equals to joint PDF of x, joint PDF of random variable x and y divided by marginal PDF of y. Is that clear to you? Similar thing will go here, y and yx. So y intersection x. What is the meaning of intersection? Comma means intersection only, right? Intersection means comma only. So xy comma divided by PDF of x. Here yx comma would come and then divided by PDF of x. So joint PDF of random variable x and y divided by marginal PDF of random variable x. This would be your y by x, y by x. Is that clear to you? Very simple. PDF of a random variable y such that x has already taken some value. PDF of random variable y such that x has already taken some value. Now from here what you can see, this particular thing could be written as fy by x multiply with fy and fy by x multiply with fx and fx by y multiply with fy. This is how fxy could be written. Is that okay for you? Right? So this is just you need to compare it with conditional probability. Similar thing is there. X intersection y. Intersection means comma. Divided by y. Divided by y. So that solve the problem, it will become more clear to you. This question they are asking. The joint PDF of x and y is given. Okay. Find the marginal PDF fx of x and fy of y. Are x and y independent? Along with that, you need to find the conditional PDF as well. All these things you need to find. Well and good. So first let's find marginal PDF. Fx of x I need to find. So what was the formula of fx of x? Do you remember? If joint PDF is given, if joint PDF is given, how will you find marginal PDF? How will you find? Sir, joint PDF is given, sir. This particular thing is given. So what I would do, I will put the limit of y. I will put the limit of y. What it will do is that it will kill y completely. In this particular expression, it will kill y completely and only x will be left. Now let me know what will be the limit of y. From minus infinity to infinity. Minus infinity to infinity. But just see the expression. Ux is connected, ui is connected. That means actually your x is going from 0 to infinity. You can add the equal sign as well. And y is also going from 0 to infinity. Are you able to understand this point? Both x and y are going from 0 to infinity. So what you can do, from 0 to infinity, now whatever the expression is there, basically this fxy could be written as this fxy x comma y. This could be written as, this expression is equals to xy e to the power minus x square plus y square divided by 2 when x is greater than 0 and y is greater than or equals to 0. Otherwise it will be 0. So from 0 to infinity, limit of y going from 0 to infinity, what you will do, you will write down this whole expression dot dy, and it is going from 0 to infinity, right? So you are integrating with respect to y. So x will become constant for you, x will completely become constant for you, and you just need to integrate with respect to y. So this is the integration you need to perform. Y into e to the power minus y square by 2 dot dy, x is constant now, x is constant because you are putting the limit of y. Here what you are doing, you are putting the limit of y, you are putting the limit of y, limit of y. So can you differentiate it? Try doing it on your own, you should be able to differentiate it. Y square by 2, what you will put? As t you will put, y square by 2 will be t. So what it is becoming, fx of x is coming out to be, just I am copying this expression, 0 to infinity y e to the power minus y square by 2 dot dy. So y square by 2 is equals to t. So from here what you are getting, y dy is equals to 2y will come, y dy would be equals to dt. And if y is equals to 0, then t will also be equals to 0. If y is equals to infinity, then t will also be equals to infinity. So what you are getting, fx of x, x e to the power minus x square by 2, t will go from 0 to infinity, y dy will be dt and e to the power minus t dot dt. When you integrate it, you will get 1, right? So what is the answer you are getting? Fx of x you are getting as x e to the power minus x square by 2. This is your marginal PDF of x, marginal PDF of x. Okay. What about fy of y? The same expression you will get, ditto same expression. You can do it. How will you do it? If I need to get fy of y, I can do the same kind of integration here. If I need fy of y, what I will do? fxy x comma y dx. X goes from minus infinity to infinity, but you know that x is actually going from 0 to infinity only. What is the expression of fxy? That is xy e to the power minus x square plus y square divided by 2 dx. I need to put the limit of x, right? Why put the limit of x? Because I need the final function in terms of y. I am putting the limit of x. What I will do is that I will take y common. So y e to the power minus y square by 2 will come common, 0 to infinity, y e to the 0 to infinity x e to the power minus x square by 2 dot dx. And when you integrate it, x square by 2 divided by x square by 2 will be equals to t. Same integration here. What you will get? 1. So fy of y is coming out to be y e to the power minus y square by 2. And one more thing, this is not completely correct. Here I have written this is not completely correct. What did I forget? I forget adding u of x here, no? Because you are solving everything considering x is also greater than 0, no? Here x is also greater than 0. Are you able to understand this point? Here if I had directly written fxy expression, so where will this ux go? Ux will say that x is greater than 0, and here ui will also say that y is also greater than 0. So here also I need to add u of y, and here also I need to add u of x. So now this will be completed, right? So now this is completed. So you are having fy of y as well and fx of x as well. Next, what you need to find? Next you need to add a page first. Let's add a page. So next what they are saying, you need to find marginal PDF. No, sorry, not marginal PDF, conditional PDF you need to find. So this is what you need to find. F x divided by y, x divided by y. So what you will do, on the upper side x intersection y would come. That means x comma y should come, divided by fy of y should come. Fy of y should come, right? What is this? This is given here, xy e to the power xy e to the power minus x square by 2 e to the power minus y square by 2 ux uy. Can I write it down in this manner? Surely I can write down in this manner. Divided by, what is my fy of y is coming out to be? Fy of y is coming out to be y e to the power minus y square by 2 uy. So e to the power minus y square by 2 will cancel out, y will cancel out, ui will cancel out. So what it is coming out to be? X e to the power minus x square by 2 ux. This is your fxy divided by and it is actually coming out to be equals to fx of x. Similar thing will happen with, similarly you can calculate your fy divided by x, y divided by x, y divided by x. So that will actually come out to be e to the power minus y square by 2 uy. You can calculate it on your own. That will come out to be fy of y. Okay. Now in the second question, what they are asking? In the second question, they are asking that x and y are independent. X and y are independent. So what you will do? If x and y are independent, then this should be equals to this. So what is this? This particular thing is xy e to the power minus x square by 2 e to the power minus y square by 2 ux uy, right? What is fx of x? Fx of x is x e to the power minus x square by 2 ux. And what is fy of y? Y e to the power minus y square by 2 uy. Is this equals to this thing? Yes. That means x and y are independent. Or what you can see, let's go back here. If A and B are independent, if A and B are independent, then what you used to do? Probability of A by B would be equals to probability of A, and probability of B by A would be equals to probability of B. So similarly here, if x and y are independent, that means PDF of random variable x such that y has taken already some value would be not depending on y. That means it would be equals to PDF of x only, and PDF of random variable y such that x has already taken some value will not be depending on PDF of x. It will only be depending on PDF of y. Is that clear to you? So fy by x should be equals to fy. So are we getting the same thing here? Fy by x is equals to fy. Fx by y is equals to fx. So here only I could have said that x and y are independent. So just we are interrelating everything with probability. Everything is interrelated with mathematics only. So needlessly you find this particular topic difficult. Okay, people will find this particular topic very, very difficult. You can ask anyone who is studying from any other resource. They will say that okay, 2-dimensional random variable, that means this is something different. 2-dimensional random variable is not different. It is 1-dimensional random variable only. Any dimension random variable is equals to 1-dimensional random variable only. You just need to have some patience and you need to solve the problem. You will be able to solve. Now people will just get confused. This expression, that expression, marginal PDF, conditional PDF, this PDF, that PDF. Nothing is there. Just relate everything with the probability and keep on solving the problems with respect to good amount of patience, and you will be able to understand everything. So x and y are independent. Here only you can tell. Right? You would not have to do this analysis, or you could have done this analysis as well, that fx of x, fy of y, if I am getting this particular thing, then if I multiply both of them, I am getting fxy only. So they are independent. Let's go to the next question. Joint PDF is given. Value of x is going from 0 to 1. Value of y is going from 0 to x. Value of y is going from 0 to x. And otherwise it is 0. You need to find the value of k, and then you need to find the conditional probability such that y is less than 1 by 8 divided by x is less than 1 by 2. So x is taking value lesser than 1 by 2, then find the probability such that y takes value lesser than 1 by 8. So try this question on your own. Use your full brain and try this question on your own. I will pause the video, I will have some break, and then I will come back and we will solve this question. This question we will solve, then we will go to this particular question, then this particular question, third question, then just we will see the concept of joint PMF, which we have already seen, and then we will solve this particular question, and with that we will be able to end this lecture. And again one more question we will solve, which is this. Okay, well and good. So yeah, let's try the problems on your own. First you try solving this particular question on your own. I will pause the video and then I will come back. Yeah, welcome back. So did you try this question? So when I see this question in the examination hall, what I would see that this is the question based on 2-dimensional random variable. That means I will have to make the surface. So let's try making the surface. Did you try making the surface? I guess if you are able to make the surface, then your job is done, and it should not be that difficult. X is going from 0 to 1, right? Let's try making the surface now. So talking about x, x is between 0 to 1. So everything will be there between these 2 points, 0 to 1. Secondly, what they are talking about y. Y is surely greater than 0. That means this lower part is gone, right? What they are saying, y is greater than 0. So this is your y, greater than 0. So only this is my matter of concern now. Now another thing is, y is greater than 0, but y is less than x. So another equation that is given is y is less than x. So for what I will do, first I will draw the graph of y equals to x. So what is the graph of y equals to x? Graph of y equals to x will be like this. I can make like this as well. Basically I can make the graph completely like this, but I will not make like this. Why is that so? Because as of now I know that this is the part which is my matter of concern. So I will make my y equals to x graph only in this particular region. This I have made. Now what is the scenario? Y equals to x. So what will be this point? This point will be 1, 1, right? Because this particular graph is y equals to x. So if x is equals to 1, then y will also be equals to 1. This will be 0, 0. Now what is the scenario? What they are saying? Y should be less than x. That means x is greater than y. X should be greater than y. So region will be this region or this particular region. What do you think? So we can put any point in this region. Let's just say, let's put this point. What will be this point? This point would be x equals to 0, y equals to 1. So if I put x equals to 0 and y equals to 1, is this equation satisfied? No. 0 is not greater than 1. That means this particular region will not come. So which region will come? This region will come. Because x is greater than y, no? So here you can see that x will keep on increasing, but y will be in this range only. Basically, you can put any point. Let's try putting this point. Here, what is the value of x? 1 by 2. What is the value of y? 0. Right? So if I put x equals to 1 by 2 and y equals to 0, yes, this equation is satisfied. That means this particular region will come into action. So now what will be your region of operation? What will be our matter of concern? So this particular region will be my matter of concern. There you go. I hope you would have done this particular analysis on your own. At least you should be comfortable with this analysis, right? So now our matter of concern is this region. This is our region R. This is our region R. What we need to do? We need to find the value of K. So what I will do? I will calculate the surface integration in this region R. In this region R, what I would do is that I will calculate the surface integration. Now what is the value of my fxy? That is kxy dot dx dy. How will the limit go? So talking about the limit, again I need to take the strip. Taking the strip, what I will see is that the limit of x is going from 0 to 1. Limit of x is going from 0 to 1. Because if you move the strip, x will go from 0 to 1 and y is going from y equals to 0 to, what is this? Y equals to x. So y is going from y equals to 0 to y equals to x. Very simple, very straightforward, right? So very easily you make the graph and your job will be done. So the only part is, the major part here is to making the region of operation, where what is the matter of concern for you. Just make that region and your job will be done. So k is a constant that will come out. Let this x be as it is, x dot dx, x will go from 0 to 1, and here if I integrate y, what I will get? Y square by 2, and it will go from 0 to 2, right? If I integrate y, what I will get? This was kxy, no? This was kxy. So if I integrate y, what I am getting? Y square by 2, and then I put the limit of x here, what I will be getting? K 0 to 1. If I put x here, what I will be getting? X cube by 2 dot dx. So what I will be getting? K x to the power 4 divided by 8 going from 0 to 1, and this will be equivalent to 1, right? This particular thing will be equivalent to 1. So now I am putting this particular thing, whatever the answer that I am getting, equals to 1. So answer of k is coming out to be 8. So k came out to be 8. Very simple, very straightforward. K is your 8. So basically your fxy now is 8xy, right? Now what you need to find? You need to find the conditional probability of probability. What you need to find in the second one? Probability of y less than 1 by 8 divided by such that x is less than 1 by 2. That means probability of y less than 8 and x less than 1 by 2 divided by probability of x less than 1 by 2. This is what you need to calculate. So for this particular thing, what will be useful? Conditional, this joint PDF will be useful for this particular thing. Joint PDF will be useful, but here you will require marginal PDF. If I need to find the probability of x taking value lesser than 1 by 2, that means I will surely require the marginal PDF. But here your job will be done through joint PDF, because here you are talking about y as well, you are talking about x as well. So how will you calculate that? We will see. So here my job will be done by joint PDF, but here I will require marginal PDF as well. So let's first make our region of operation. This was our region of operation. So let's make the diagram again. Let's make the diagram here again. So our region of operation was this much. X is going from 0 to 1, and this equation is y equals to x. So this point is 1 1. This line is y equals to x, and this was our matter of concern. Now what they are saying, what you need to find, you need to find the probability such that y is less than 1 by 8 and x is less than 1 by 2. Y is less than 1 by 8 and x is less than 1 by 2. So where will be your y equals to 1 by 8? Y equals to 1 by 8, where it will be? Let's remove this as of now. This is my x axis, this is my y axis. So y equals to 1 by 8 would be somewhere here. This is your line of y equals to 1 by 8. So what they are saying, y less than 1 by 8, that means this will be the matter of concern now, and x less than 1 by 2. So where will be your x less than 1 by 2? X less than 1 by 2 would be somewhere here. Let's just say this is your 1 by 2, this is your 1 by 2, although it will be right in the middle, so let's call this as 1 by 2. So x is equals to 1 by 2. So what they are saying, y should be less than 1 by 8, that means this particular region, and x should be less than 1 by 2, that means this particular region. And in these region, which will be the matter of concern? Only this much part will be the matter of concern. Are you able to understand this point? Now this much part will be our matter of concern. Did you understand this point or not? Look, this thing came later on. First what was given? First this was given that x is going from 0 to 1 and y is going from 0 to x. So from there what we got to know, that this is our matter of concern. This much is our matter of concern. This triangle is our matter of concern. This is our region of operation. Then another condition was y should be less than 1 by 8. That means you are coming downward, and x should be less than 1 by 2. That means this much region is now now our matter of concern. So whatever the probability you are getting in this region, let's call this region as r dash. So this would be equals to, in the region r dash, you will take your joint PDF and you will integrate it. You will integrate your joint PDF in this particular region. And how will you integrate? How will you integrate? Here again you need to choose the strip. But how I should choose the strip? If I choose the vertical strip, what will happen? Look here, smartly I need to choose the strip. Let me show you one thing. You go to know what is our region of operation. So this is our region of operation, but here I need to choose the strip. So this is our region of operation that you have understood. So if I choose the strip in this manner, if I choose a vertical strip, let's just say if I choose vertical strip. So this vertical strip I have chosen, right? So when I move the strip, limit of x will go from 0 to 1 by 2, no doubt about that. But how the limit of y will go? So till this point what will happen? Limit of y will go from 0 to x, right? Because this line is y equals to x. What is this line? This line is y equals to x. So when this strip is moving, so till this point, till this particular point, the limit of y will go from 0 to x. But just as the strip becomes here, just as the strip comes here, the limit of y will go from 0 to 1 by 8. So you will have to break two limits if you are taking the vertical strip. If you take the vertical strip, you get to know that till this particular point, till this point, y is going from 0 to x. Y is going from 0 to x. But after that, what is happening is that y is going from 0 to 1 by 8. So this is our issue. So what I will do is that this time I will try taking the horizontal strip. If I take horizontal strip, what will happen? Let's try taking the horizontal strip. If I take the horizontal strip, so in horizontal strip, what do you see? Limit of x will go from limit of x. Here x is equals to y. and here x is equals to 1 by 2. So limit of x will go from y to 1 by 2, and you move the strip upward. Always, even if the strip is here or the strip is here, always what is happening, x is going from y to 1 by 2. And what about the limit of y? If you move the strip upward, so y is going from 0 to 1 by 8. Are you able to understand this point? If you have studied the surface integration, then you will be able to understand. I have taken the vertical strip this time. So vertical strip, limit of x is going from y to 1 by 2. Limit of x is going from y to 1 by 2. And limit of y is going from, if you move the strip upward, and downward, what do you see? Limit of y is going from 0 to 1 by 8. Say yes or no. So this is how I can do it. Limit of y goes from, constant limit always we will put here. Limit of y goes from 0 to 1 by 8. But limit of x goes from y to 1 by 2. Right? Well and good. And now someone will be saying, sir, why I cannot write 1 by 2 to y? Why I cannot write 1 by 2 to y? So you should have watched the video of integral calculus. There I told you limit will always go from lower limit to higher limit. And here I know that condition is x greater than y. X greater than y. So here what you are saying, x is going from y to 1 by 2. X is going from y to 1 by 2. So basically this will be the lower limit only, no? Here value of x will be lower and here value of x will be larger. Forget about this particular thing. In this strip if you are moving, so here the value of x is low. That would be somewhat this point that I don't know. And here the value of x will be 1 by 2. So always you will go from lower limit to higher limit, y to 1 by 2, right? And in the upward side, y is going from 0 to 1 by 8. How it is going 1 by 8? You understand, right? So you just need to understand that our region of operation is this much this time. This, and this. This is our region of operation. Okay, this is our region of operation. This particular diagram that I have made. This, and this. This is our region of operation. So in the strip, limit of x goes from y to 1 by 2 and limit of y goes from 0 to 1 by 8. Okay. So here fxy is given as kxy. What is the value of k is coming out to be 8, right? So 8xy dx dy. So you are first integrating with respect to x this time. So limit of y remains as it is. Then if you integrate with respect to x square by 2, y to 1 by 2, right? So what this will become? Four y 1 by 4 minus y square by 2 dot dy. Oh, dy was already there. Just I am integrating nothing else. 8y I took as constant. X square by 2, limit is going from y to 1 by 2. So here if I put 1 by 2, I will get 1 by 4 minus y square. 1 by 4 minus y square. Y square by 2 I am writing. 1 by 2 minus y square I will get. If I put 1 by 2 here, so 1 by 4 minus y square, 2 I have cancelled out. So this will become y. This will become 4y. So here I will get this particular thing, right? And when I put it inside, so y minus 4y cube. This will be y minus 4y cube. So simply it is coming out to be y minus 4y cube dot dy, right? 4y 1 by 4 and y square 4y cube. Yeah. So what you are getting now? Y square by 2 minus y to the power 4 divided by 4. So 4 will get cancelled. 0 to 1 by 8. So what you are getting? 1 by, I will just solve it using the calculator, okay? Whatever the answer I get, 1 by 8 to the square divided by 2. 1 by 128. 1 minus 1 by 8 to the power 4. This is what I am getting. 1 by 8 square divided by 2, 128. 1 by 8 to the power 20. So let me solve it using the calculator. Yeah, so after the calculation, this answer would come 31 by 4096. Okay, so this job is done. Which job is done? That we have find out y less than 1 by 8 intersection x less than 1 by 2. So this is coming out to be 31 divided by 4096. Now next we need to find probability of x taking value lesser than 1 by 2. So for this, what do we require? Just let me know what will be the answer of this. That means here what you will require, fx of x dot dx, x taking value lesser than 1 by 2. X is taking value from 0 to 1. That means now it will take value from 0 to 1 by 2. So what you would require? Fx of x you require. So what do you need? Fx of x. So first I need to find fx of x. How will I find fx of x? Very easily I can find fx of x. What I will do? Right? And now I need to put the limit of y. What I need to do? I need to put the limit of y. So how the limit of y is going? Limit of y is actually going from 0 to y equals to x. What I mean to say is that, again, if you see the region of operation, what I need to find, now I am finding the marginal PDF of x. What I am finding? Marginal PDF of x. What is my region of operation? Region of operation is this much. That I have already seen. This is my region of operation. From 0 to 1, 1 comma 1. Right? Now what I am doing? I am integrating with respect to y. That means I need to see the limit of y, no? So from where to where limit of y is going? So limit of y is not constant. Can you say that, sir, limit of y is going from 0 to 1? No. Limit of y is going from 0 to x. Limit of y is going from 0 to x. Basically, limit of y is going from 0 to x. Like in y direction, you are not going from 0 to 1. Always you are not going from 0 to 1. If you start from here, 0 to x, 0 to x, 0 to x, 0 to x. That's it. So limit of y is from 0 to x. Right? So limit of y is from 0 to x. So what is your fxy? That is 8xy, right? The value of ki came out to be 8. So 8xy dy. 8xy dy. Limit of y is from 0 to x. So 8x y square by 2, 0 to x. So 4x cube you are getting. So this is your fx of x, right? X square, x cube, 4x cube. Now what I need to find? I need to find probability of x taking value lesser than 1 by 2. This is what I need to find. So 0 to 1 by 2, 0 to 1 by 2, 4x cube dot dx. So that would become x to the power 4 divided by 4, that will be cancelled out, 0 to 1 by 2. So it would be 1 by 16. So this answer is coming out to be, for this particular thing, answer is coming out to be 1 by 16. So what will be the answer? So simply the answer would be 31 by 4096, 31 by 4096 divided by 1 by 16. So again let me pause the video and again let me do the calculation. Yeah, so the answer is coming out to be 0.121. Okay. So very easy question it was. If you see, like, people would find it tough, but if your concept is clear, you know how to make the diagram, everything is crystal clear to you, right? So we started from here. We need to find, you need to find the value of k. That is very easy. You will be able to find the value of k. You just need to work on the given region and you need to find the surface integration. You found out the surface integration, that would be equivalent to 1. So value of k is coming out to be 8. Now in the second question, you need to find the conditional probability such that y should be less than 1 by 8 and x should be less than 1 by 2. Here, in place of intersection, what I can do? I can put the comma as well. So x should be less than 1 by 2. So our region of operation was already this much. In that region of operation, x should be less than 1 by 2 and y should be less than 1 by 8. So now this is our region of operation. So you could have taken the vertical strip as well, you could have taken the horizontal strip as well. In vertical strip, I will have to break the integration in two parts. That's why I took the horizontal strip. In the horizontal strip, what I am getting? That value of x is going from y to 1 by 2 and value of y is going from 0 to 1 by 8. So that I put here, I got the answer for this particular thing, and then I needed to find the probability of x taking value lesser than 1 by 2. That means I would require here marginal PDF of x, fx of x I would require, and then from there I can get the value of x lesser than 1 by 2, and x is already starting from 0, so 0 to 1 by 2. So I need to find the marginal PDF of x. So for that what I would do, fxy dot dy. Now I need to put the limit of y. So y is not going from 0 to 1, y is going from 0 to x, y is going from 0 to x, and directly clearly you can see from here y is going from 0 to x. So that I put here 8xy dot dy. So 8x y square by 2, 4x cube I got, and then I calculated the final answer, and then I divided them. There you go. Very simple. Yeah, sorry for the interruption guys, I got a work in between. So we have solved this question. Now we need to solve this particular question. Fxy is given, the limit of x is given, the limit of y is given. You need to find the probability of y taking value between 0 to 2. So this is something that I need to find, probability of y taking value between 0 to 2. So from here I got to know that I would need the marginal PDF of y, right? I would need the marginal PDF of y. If I have the marginal PDF of y, then my job will be done. But for finding the marginal PDF of y, you need to take reference of this one. And when you take the reference of this particular thing, your answer will come in terms of c, no? So you need to kill this c. Basically, you need to find the value of this c. Are you able to understand this point? This c is a constant, no? Like in the previous questions, we were finding the value of this constant, right? K. We found the value of this constant. The value of k came out to be 8. That's why our answer came at some value, as some numerical value. If you want the answer in some numerical value, that means it should not be coming in terms of c. So first you need to find the value of c, then you will solve the problem. So if they are asking this particular question in the examination, then most probably they will give the value of c. Basically here they will write down some constant value, okay, most probably. But here we are learning this particular topic, so that's why we will solve the problem on our own. We will find the value of c. So for finding the value of c, what you will do? You know one particular thing. What do you know? That in my region R, like x is going from some particular value to particular value, and y is going from some particular value to some particular value. So in this region R, if I calculate the surface integration in this region R, if I calculate the surface integration, that will be equals to 1, and using this particular identity I can find the value of c, right? So what I will do now, I will find the region R, which is very important. So what is given? X is going from 0 to 2. So let's talk about x first. So x is going from 0 to 2. So one thing you understood, that everything will be between 0 to 2 only. So in this region everything would come. Till this point you got these 2 points, right? Now this time what they are saying, that y is less than x and y is greater than minus x. So basically again you need to draw 2 lines, y equals to x and y equals to minus x. So you need to draw y equals to x and y equals to minus x, because 2 inequalities are there, y greater than x and y less than x and y greater than minus x. So this line is y equals to x and this line is y equals to minus x. So first inequality will say that y should be less than x, that means x should be greater. So just think about any point. If this point is 2, so what this point will be? 2 comma 2, because y is equals to x, and what this point will be? 2 comma 2. Now take any point. Let's just say I take this point. This point will be x value is 1, y value is 0. So if I put this point here, y value is 0, x value is 1. In this inequality I am putting y value 0, x value 1. That means it is satisfied. So this will be the region of operation. So what will be the graph of y less than x? This is the graph of y equals to x. The graph of y less than x will be this much, right? This much, the downward region. What about this particular thing, that y greater than minus x? So either the region will be this one or region will be this one. Basically either the region will be this one or the region will be this one. So what will be the region? So y should be greater than minus x. So let's take any point. Let's take up any point. Let's take the point here. Let's take the point. Let's take this point only, 1 comma 0. So if I put y equals to 0, then there is a minus sign and x equals to 1. So 0 is greater than minus 1. Yes, that means this particular region is satisfied. So this inequality is saying that the region is downward, and this inequality is saying that the region is upward. So what will be the region? This common region will be there. Are you able to understand this point? So now this is our matter of concern. This particular region is our matter of concern. Did you understand how did I calculate the region? This should be done by you on your own. At least this much calculation you should be comfortable. You should be doing this much calculation on your own. So this is our region of operation. Okay. Like some very good level of problems we are solving here. Okay, very good level. What we need to do? In this region we need to integrate and we need to find the value of c. So what I will do? I will choose the strip. I can see that value of y will be going from minus x to plus x, right? Value of y will be going from minus x to plus x, but value of x will be going from 0 to 2. So value of x will be going from 0 to 2. Value of y will be going from minus x to plus x. Cx x minus y dx dy, that would be equals to 1. Now this integration you should be able to solve. So this time there is a minus sign in between, so you have to break the integration. No, basically if you solve this particular thing, what you will get? If you solve this one, what you will get? Cx square minus cxy. So cx square dx dy, cxy dx dy. So how will you break it? X is going from 0 to 2, y is going from minus x to plus x, right? So cx square dx dy minus x is going from 0 to 2, y is going from minus x to plus x, cxy dx dy. So first I will solve the integration of y, then I will solve the integration of x. So if I solve the integration of y here, what I will be getting? Cx square dx will come outward. Integration of dy will be y, then plus x minus x will become 2x. So now I will do the calculation in a quicker manner, okay? Because you can do this calculation on your own. So this is coming out to be 2x cube actually, dot dx. Integration going from 0 to 2. How did I do it? Dy, this will be constant. Integration of dy will be what? Y only. Limit going from plus x to minus x to plus x. That means 2x would come. So 2x will be multiplied with cx square. That would be 2cx cube. Well and good. Now if you integrate it, what you will be getting? 2c x to the power 4 divided by 4 going from 0 to 2. This is what you will be getting. So integration I have done only in one step. What about this one? So here what you will do is that cx dx, that will be common, and y square by 2, and limit of y you will be putting from minus x to plus x, and x will be going from 0 to 2 dot dx. So if you put plus x here, x square will become, if you put minus x here, again it will be x square only. So this integration will throw 0. So this particular thing is equals to 1. So what you are getting? 1 by 2, 8c, c is coming out to be 1 by 8. So when you solve this integration, c is coming out to be 1 by 8. All these should be done on your own, right? Because this is not the tougher task. This is the simpler one. C is coming out to be 1 by 8. Now what we need to do? We need to find fy of y. Say yes or no. C is 1 by 8. So basically my fxy is done. Now this was my first task. My fxy is done, which is 1 by 8 into x minus y. Now next is I actually need to calculate this particular thing, and here I would require fy of y. So how do I calculate fy of y? So I know that fxy x comma y dot dx, and now I need to put the limit of x. So will I put the limit of x from 0 to 2? What I am saying is that here I need to put the limit of x, right? If I need to find marginal PDF of y. So you can see that x is going from 0 to 2. So you should put x from 0 to 2. Is that so? Wrong. No. You cannot do it. X is going from 0 to 2. No. Like this you cannot do it. No. This is your region of operation. So how will you define the limit of x? First make the region of operation. First make the region of operation. Let's do it on the next page. So first I will make the region of operation. What was my region of operation? So this was my region of operation. In this region I was working, right? In this particular region I am working. Here I know that this point will be 2 comma 2, this point will be, actually this point will be minus 2 comma minus 2, right? Sorry, plus 2 comma minus 2, plus 2 comma minus 2, 2 comma 2 plus 2 comma minus 2, 0 comma 0. This is your x, this is your y. Very, very important point of this question, because everyone would have done the same thing, that sir, x is going from 0 to 2, just put it. No, actually you need to take the limit of x. So in this particular region, how the limit of x is going? So I will choose the strip, no, if I need to take the limit of x. In this particular region, how the limit of x is going? So how will you define it? You need to choose the strip. So if I choose, let's just say if I choose this strip. So what was the equation of this line? Y equals to x. And what was the equation of this line? Y equals to minus x. So here I will say that, sir, my limit, my strip will go from, my limit of x will go from, limit of x will go from y to, limit of x is going from, because here x equals to y and here x is equals to 2. On this line x is equals to 2. So limit of x is going from y to 2. But this strip will always work. If your limit of x is going from y to 2, then move this strip. If you move this strip upward, what will happen? Y will go from 0 to 2 only, because let's just say if this strip come downwards, what I am saying is that if this particular strip is coming downward, then what will happen? Just as it reaches here, x will change its limit, no? X will change its limit, because this particular equation is y equals to minus x, or you can say x equals to minus y. So now your x will be going from minus y to x equals to 2. So here this particular strip will say that x is going from minus y to 2. Here this strip is saying that x is going from y to 2. So when you move this strip upward and downward, so from here to here the strip is saying something different, and from here to here the strip is saying something different. Is that clear to you or not? So this is how you will take the limit of x. It's not that sir x is going from 0 to 2. Doesn't make any sense. You need to see in the region, in this particular region of operation. You are working in this particular region, so you will take the strip. X is going from y to 2 and here x is going from minus y to 2. How the y is going? In this particular region, y is going from, in this particular region, y is going from 0 to 2, right? If you move the strip upward, so y is going from 0 to 2. Here y is going from 0 to 2, right? And what about the, this is the region 1, this is the second strip, where x is going from minus y to 2 and y will go from minus 2 to 0, because I always told you from lower to higher we need to go. So y will go from minus 2 to 0. Is that clear to you or not? So if I need to find my fy of y, then I will find it for two different regions. In one condition I will put that if my limit is from y 0 to 2, if my y is going from 0 to 2, then what will be my fy of y? So there what I will do is that fxy xy dx dy, sorry, not dx dy, dot dx, and x will go from y to 2. Is that clear to you or not? When your y is between 0 to 2, when your y is between, basically you let me know in this particular region what is the range of y. Y can take the value between minus 2 to plus 2. Say yes or no. Just as you made the diagram, you got to know that y can take the value between minus 2 to plus 2. So if you write down your fy of y, so what will happen? Here some expression will come, here some expression will come, and if your y is greater than 2 or less than minus 2, then fy of y will be 0, because you know that fy can take value between minus 2 to 2 only. Then you got to know that if y is taking value between 0 to 2, when y is taking value between 0 to 2, then limit of x is something different. Limit of x is from y to 2, and when your y is taking value from -2 to 0, then your limit of x is something different. What is your limit of x? Then your limit of x is -2 to, then your limit of x is from -y to +2. A very good point we are seeing here, okay, very good point. And believe me guys, 99.9999% student will fail here if this question is coming in the examination. A very good question. So blindly just looking at the question, you will never solve the problem of a two-dimensional random variable. Always you will make the region of operation. Once the region of operation is made, what you need to find? You need to find the marginal PDF of y. So if I need to find the marginal PDF of y, first thing I will see that from where to where my y is going. In this particular region, from where to where my y is going? My y is going from -2 to +2. Now in this region, how my x is going? So in this region from -2 to +2, how your x is going? So for that you have to choose the horizontal strip. So you will say that, sir, in this particular region, x is going from y to 2, and in this particular region, x is going from -y to 2. So that means I need to break it into two parts, 0 to 2 and -2 to 0. Okay. So this calculation I have to do now. Is that clear to you or not? So I will get the answer of fy of y here, and then what I will do? After that, I will calculate this particular thing. But just think about it, what we need to find? Probability of taking y taking value between 0 to 2. So do you really think that you need to solve this particular part? What I am saying, do you think that you need to solve this particular part? Because what is required? You need to find the probability of y taking value between 0 to 2. This is what you need to find. Say yes or no. Random variable y taking value between 0 to 2. So you will require the marginal PDF, but you will require the marginal PDF only in the range of 0 to 2 only, no? If the question was find the probability of y taking value between -1 to 2, then you would say that, sir, from 0 to 2 this PDF will come. Then you will say that, sir, from 0 to 2 this PDF will come, and from -1 to 0 this PDF will come. So then you would find both of the PDF. But as of now, my matter of concern will be only this PDF, no? So why would I care about finding this particular PDF? Basically, here what I will write down is that if your y is between -2 to 0, then some answer would come. And if your y is between 0 to 2, then some answer would come. Now, when I find this probability, what I will do? I will integrate from 0 to 2 fy of y. Then I will go here. What I will see from 0 to 2, what is the value of fy of y? This is the value. So I will put this value here, and then I will do the integration, and I will get my final answer. That means what will be my matter of concern? Only this will be my matter of concern, no? So if you want to get this particular value, that means you need to solve this integration only. There you go. So needlessly, I will not solve this particular integration. Okay, only I will solve this integration. So I will add a page. I will tell you a shorter method as well, that how you can solve it in quicker manner. Like this is a longer method. Here you need to find fy of y, but there will be a shorter method as well. Okay, you try thinking what could be the shorter method, but as of now, let's go by the longer method only. Limit of x is going from, because in the examination, at first glance, this method will click, right? At the first glance, this method only will click. What is the value of fxy? This is a very good question actually. Who made this question? AI. Okay. What I do is that I frame some question roughly, and then I put it in ChatGPT, and then I ask them that please modify the question in a very good manner. You can just frame a question and then put in the ChatGPT, and you tell it that you make it on the tougher side. You make this question on the tougher side and conceptual. Then they can reframe the question. So this is what I do. Okay, I use ChatGPT a lot nowadays for teaching purpose. Okay, never use AI for your personal things, right? Let's just say you broke up with someone, or you got into a fight with someone, then you are feeling down, and you share your feelings with AI. This is what nowadays people would do, right? But never ever do it. You never know how they can use the information against you. Okay, so for studying, for professional work, always you can use AI, but for personal work, never ever use it. Okay, I have seen some memes as well on Instagram that like some guy is using AI for talking to some girl. Okay, this kind of meme I saw. So then I realized that okay, people would do it. People would be doing these kind of things. But yeah, it is not it is risky actually. Okay, yeah, so x square minus xy dot dx. So x is going from y to 2, right? So 1 by 8 is outward, x cube by 3 minus x square y by 2 from complex expression we will be getting basically. Okay, this will be a complex expression. So let's write it down. Here 2 would come, so 1 minus 2y minus y cube by 3 plus y cube by 2. Is that so? Okay, let's check back again. X into x minus y, x square, x cube by 3 minus x square by 2y. X is going from y to 2. Then I put 2 here. Wait a minute, yaar. If I put here 8 by 3 would come, no? 8 by 3, what I am doing? This would be 8 by 3, right? 8 by 3 minus, if I put 2 here, so 4 2y, then I put y cube minus 3 and then plus y cube divided by 2. Yeah. So if you solve it, what you are getting here? 1 by 2 minus 1 by 3, 1 by 6, right? So this I can solve. 1 by 3 minus y by 4 plus y cube by 48. Okay, this is your fy of y, but with the condition that your y is between 0 to 2. Your y is between 0 to 2. But you don't care about this fy of y. Now what you need to do? You need to find probability of random variable y taking value between 0 to 2. So y is taking value between 0 to 2. So 1 by 3 minus y by 4 plus y cube by 48 dot dy. So y by 3 minus y square by 8. Let me check back the calculation. I am not comfortable with the calculation. I don't think this calculation is correct. So let me check the calculation and you also proceed in the calculation. Yeah, so actually I was going in the right direction only. Everything was correct. Calculation was correct. You just need to put the value. So it might happen that in the examination it may feel like that, sir, y to the power 4 divided by 4, something is going wrong. But actually when you solved it, answer is coming out to be 1 by 4. Okay. So a good answer, 1 by 4 is coming. So that's the answer. Okay, well and good. So it was a good question. Let's understand method 2. Let's think about it. Let's think more before going into mathematics. What you need to find? The probability of y taking value between 0 to 2. This is what you need to find. So let's get back here. This was the question. They are asking probability of taking y value from 0 to 2. That means x can take any value, no? If I say I am having two random variable x and y should take value between 0 to 2. I am not telling anything about x. That means x can take any value. That means x can take value from 0 to 2. So value of x could be anything. Value of x could be anything. Value of x could be anything. But value of y should be from 0 to 2. Value of y should be from 0 to 2. Just think about it. Value of y will be from 0 to 2 from that will be in which region? Think about it. Value of y from 0 to 2. Here y is equals to 0. Here y is equals to 0. Then y is equals to something. Then something. Then something. Let's just say y equals to 1 here. Then something. Then something. Then something. Then something. Y equals to. So 0 to 2 will be here. Value of y will be 0 to 2 here. And x could take any value. X could take any value. So aren't we talking about this region only? Are you able to understand this point? Value of y from 0 to 2 and value of x could take anything. So in horizontal direction you could take anything. Someone will say that, sir, I can take this as well. Yes, you can take this as well. But y should be from 0 to 2 only, no? Y should be from 0 to 2 only. So that means what we are talking about? We are talking about only this particular region. We are talking about only this particular region. So what you needed to do? You need to find the you need to find the surface integration in this particular region. Now, are you having this doubt that sir, whole region will come 1? So this is like half. So answer should be half. Don't do it, okay? So this is surface integration. It is not dx dy. It is not only the area. It is the surface integration. Surface integration with respect to this function. So there is a function as well, no? Like those who don't have a good idea of integral calculus, they will think that, okay, sir, this is complete 1, because this complete area would be 1. That I already know. This is what I have equated. So this complete area would be 1. So sir, now you are saying that I need to integrate from here to till here. That means I need to integrate in this particular surface. So the whole is 1. So this is like half. So answer should be half. 1 minus half will be equals to half. No, don't do that. You are integrating with respect to a particular function, which is this function. So this particular function can change the scenarios, no? Basically, this particular function will have different value in this region, and this particular function will have different value in this region. So this function is having different values in both of the region, no? Are you able to understand this point? Cx into x minus y, it will be different here, it will be different here. So your surface integration will also be different. So this is actually coming out to be 1 by 4. And this downward will come out to be 3 by 4. Is that clear to you? So okay, don't use your brain like this, that half, so answer should be half. No. Because if this question is coming in the examination, surely in the option half will be mentioned. So did you understand this point, what I was saying? That y is from 0 to 2, y is from 0 to 2. And x could take any value, x could take any value. That means we are working in this region. So what I need to do, I need to calculate the surface integration. If I am directly considering the, what we are considering, I am directly considering the joint PDF. If I am directly considering the joint PDF, that means I need to integrate with respect to x as well, with respect to y as well. You know that x is going from 0 to 2. In this region, x is going from 0 to 2. And if I take a horizontal strip, what I would see, that my y is going from 0 to x. You are not going to put y is going from minus x to x. In this particular region, if you take a horizontal strip, then x is going from 0 to 2 and y is going from 0 to x. So you put the value and you solve this, you will get the answer 1 by 4. Do it on your own, okay? If I mean something to you, if this channel means something to you, if communication system means something to you, if gate examination means something to you, then you will do the calculation on your own and you will check whether you are getting 1 by 4 or not. And in the comment section, you will type down, yes sir, I got the value 1 by 4. Okay? That means you are actually enjoying the lecture, you are actually learning from this lecture. And those who have already studied this subject, they would realize that what kind of depth has been covered here. Are you really able to understand the meaning of two-dimensional random variable now? Okay? So how random variable y is taking value, how random variable x is taking value, and how they are together taking the value. This is something that we are learning, right? So yeah, this was a very, very good question. I spent roughly around 30 minutes on this question, just to make you understand that if you are finding fy of y, directly don't go here, okay, x is going from 0 to 2. Always two-dimensional random variable, that means I will make the region of operation first. If I am making the region of operation, now I know that if I need to find my fy of y, that means now I need to put the limit of x. So this was absolutely wrong. So now I will go to my region of operation and now I will see that my y is actually going from minus 2 to 2. My y is actually going from minus 2 to 2. In this range, when my y is going from minus 2 to 2, how my x is going? So when my y is going from minus 2 to 0, then my x is going from minus y to plus 2. And when my y is going from 0 to 2, at that time my x is going from y to 2. As per the question, I am interested only in fy of y from 0 to 2 only. That's why I will calculate this particular thing and I will get my answer from here. So I calculated this particular thing, I got my answer. Okay? And if I don't want to find the marginal PDF, directly I need to think. Directly, how will I think is that they are asking y should be between 0 to 2. So x could be anything. That means this is the region of my operation. There you go. So very easily I could have got the answer here. But the important part was that how you find the marginal PDF. Right? Okay. So let's do this question. Here actually, when AI framed this question, they framed the question in this manner that find the value of k. But this task you can do on your own, right? How you can find the value of k? You will make the region of operation and then you will do the same thing, right? So you can find the value of k on your own. In the region of operation, what you will do, fxy xy dx dy, that should be equals to 1. So that task you can do on your own. So as of now what I will do is that, अरे भाई क्या वैल्यू थी यार, was it 8? This is not a live lecture. I guess it was 8 only. We can verify. Okay, we can verify. As far as I remember, it was 8. So you can find the value of k. It will come out to be 8. As far as I remember, it was 8 only. Okay. Now what you need to find actually? You need to determine the conditional PDF. Fy of x, y by x. Here they are saying that x is taking value 1 by 2, which we can put later on. Basically, what this would be equals to? You know that this would be equals to your joint PDF divided by your marginal PDF. Say yes or no? Joint PDF divided by marginal PDF. Once you calculate this particular thing, what you need to do, x equals to 1 by 2 you need to put. So what you will do, here you will put x equals to 1 by 2. Okay. So what is the task here? What is the task? The only task is I need to calculate this particular thing because joint PDF is already given. What I need to calculate? I need to calculate fx of x. So what I need to calculate? My only task is I need to calculate fx of x. So what do I know? I have to do this particular thing. Then I put the limit of y. So how will I put the limit of y? From here, that y is going from x to 1. No, always draw the graph. So how will you draw the graph of this one? So what all information are given? That your x is greater than 0. First information is that x is greater than 0. That means you are working in this region now. X is greater than 0. So this is your x, this is your y. So from the first information you got to know that x is greater than 0. And second information you got to know that y is less than 1. Y is less than 1. So let's make y equals to 1. This would be your y equals to 1. So y is less than 1. That means now this is your region of operation, right? X cannot be negative, y is less than 1. So this is your region of operation. Now what is the other information? That x is less than equals to y. That means now I need to make the graph of x equals to y as well. So I made the graph of x equals to y as well. This is the graph of x equals to y. X equals to y. And this was the graph of y equals to 1. So what will be this point? This point will be x equals to 1 and y equals to 1. Say yes or no, right? Now what they are saying, x should be less than equals to y. X should be less than equals to y. So either this region will come or this region will come. So let's take any random point. Let's take this point. Here your x value is 1, y is 0. So put here 1 should be less than equals to 0. Is this inequality true? No. That means this region will not come. So which region will come? Upper region will come. So this is saying that downward region should come. This is saying that upper region should come. And this is saying that x should be greater than 0. So what do you think, which is the common region? This is the common region. Very easily I can see that this is the common region. Say yes or no, right? This is the common region. So till this point you should be having the habit of making this kind of graph. So this is my region of operation. If I needed to find the value of k, then I could have find the value of k as well. How would I find it? I will integrate in this region R. So in this region R, what I would have done, I would choose a strip. I would choose a strip, vertical strip if I am choosing. So your limit of y is going from x to 1. Limit of y is going from x to 1. And limit of x is going from in this direction if you go. Limit of x is going from 0 to 1. 0 to 1. This is, let's just say this was kxy dx dy. So when you solve it is equals to 1. So when you solve it, k should come out to be 8. Okay. Now what is our task? Our task is to find fxy dot dy. I need to put the limit of y. I need to put the limit of y. So what I will do, I will take the horizontal strip and you can see that y is going from x to 1. So y is going from x to 1. Did you understand this point? If you take this horizontal step, you know that y is going from x to 1. So y is going from x to 1. What is your fxy? 8xy. So 8x is constant, y square by 2. So this will become 4. X to 1. So 4x into 1 minus x square. This is what you are getting, right? fxy you put, fxy I put 8xy, and y is going from x to 1. Here also you can see y is going from x to 1 only, or in this diagram as well you can see y is going from x to 1. So always better you make the diagram, because if you don't make the diagram, you will surely mess up here. You will do this kind of mistake. Okay, the answer would be different. Yeah, so y is going from x to 1. Well and good. Yeah, y goes from x to 1, and then y square by 2, 4 x y square, and x to 1, 1 minus x square. So this is my fx of x. This is my fx of x. This I need to calculate at x equals to 1 by 2. So what I need to calculate? Fx of x equals to 1 by 2. So 4 into 1 by 2, 1 minus 1 by 4. So that would be 2 into 3 by 4, 1.5, right? And in this question, if you put x equals to 1 by 2, what you will be getting? Basically, what is the value of fx y? X equals to 1 by 2 you need to put, and in place of y you need to put y only. So that is equals to 8, x value I need to put 1 by 2, and I need to see that x equals to 1 by 2 if it is taking or not. Basically, value of x takes the value 1 by 2 or not. Yes, it takes. Value of x goes from 0 to 1. Value of x goes from 0 to 1. So yes, it takes the value 1 by 2. So that's why I will be able to go to 1 by 2 here into y. So what will be the answer I will be getting? 4y. What you are getting? 4y. So basically, what will be the answer of this particular question? Answer of this particular question, they are asking f of y by x, f of y by x, small y, x equals to 1 by 2. So that would be equals to what? So on the numerator, what value you will put? X equals to 1 by 2y, that would be 4y, and in the denominator what you will put? 1.5, or you can say 3 by 2. So the answer would be 8y by 3. This is the answer. Okay. So what they are asking? PDF of random variable y, PDF of a random variable y such that x has already taken the value 1 by 2. So that is 8y by 3. X has already taken value 1 by 2. So what is the PDF of y? This is what they are asking, that is 8y by 3. This is the answer. All good? All fine? Very easy question. This was very straightforward. You just need to write down the formula. Then in fx of x you need to put 1 by 2. So you find out the value of fx of x. Very easily you could find out the value of fx of x. How would you find out the value of fx of x? You need to put the limit of y, then you put the limit of y square by 2, 4x here, 1 minus x square, fx of x you got, then at 1 by 2 you check the value, that would be 3 by 2, right? So this value is coming out to be 3 by 2, and fxy, xy was already given, and you need to put x equals to 1 by 2 here. So I need to put x equals to 1 by 2 here, so 4y divided by 3 by 2, so 8y by 3. This is the answer you are getting, okay? Joint PMF, we have already discussed about it. What is joint PMF? So what was your Px of x? It would tell the probability of random variable x taking value small x. So what would be your Pxy, xy? Probability of random variable x taking value small x and random variable y taking value small y. Very simple. It is PMF, right? Joint PMF or simple PMF should be very simple for you. What would be your marginal PMF? So from the joint PMF, how would you find out marginal PMF? What do you think? What I need to find? What I need to find? I need to find this particular thing. Let's just say my random variable x is taking value 0, 1, 2, and my random variable y is taking value 2, 3, 4. Now what I need to find? Px of 0. That means I need to find the value such that x takes value 0. This is what I need to find. So what I would do, x can take the value 0 when y is 2, x can take the value 0 when y is 3, and x can take the value 0 when y is 4. Are you able to understand this point? X can take the value 0 when y is 2 or 3 or 4. That means what you will do, you are having this marginal PDF. In this marginal PDF, whatever the value of y is there, you will put all the values of y. If you are not able to understand with respect to the formula, you will understand with respect to the question as well. Or just try thinking, no, just try relating it with PDF. In PDF, what we used to do, if I need to find fx of x, what I would do, I would take this and then I integrate with respect to y and put the limit of y. That means whatever the value y can take, all I will put. So here as well I am doing the same thing. Integration has been changed to summation. This PDF has changed to PMF. PDF has changed to PMF. And all the limit of y I am putting. All the limit of y I am putting. So whatever the y can take the value, y can take the value y1, y2, y3. So all the values of y I will put. So don't stress much on the formula. You will understand it. Don't stress much on the formula. You will understand it. Okay. Don't worry about it. We will solve the problem. Everything will be clear to you. Here what I would do. Here again I will take the joint PMF. But now I will put all the values of x. Okay. We will understand it with respect to a question. If you are not able to understand, don't worry. What about this one? Conditional PMF. Conditional PMF would be x comma y divided by marginal PM divided by marginal PMF. Divided by well and good. Okay, very simple thing. So forget about all this, forget about this slide. This slide you don't even need to revise. You will directly revise this question. This question has everything. So what they are saying, the joint PMF of random variable x and y is given. X can take the value 0, 1, 2 and y can take the value 1, 2, 3. You need to find all these things. Y taking value 1, y taking value 2, y taking value 3, x taking value 0, x taking value 1, x taking value 2. Then x is greater than 2, y is less than 1, x plus y greater than 3, x equals to 1, y equals to 3. All these things you need to find. Just think about it, what this PMF is representing. Px, y. What this PMF represent? PMF represents us that random variable x takes value small x and random variable y takes value small y. If I ask you what is the value of 1, 2, what does that mean? I am telling that random variable x should take the value 1 and y should take the value 2. So what I would do, I will put the value small x equals to 1 here and capital Y, small x equals to 1 here and small y equals to 2. So I will get k into 1, 8k I will be getting. Here you put 2, so 3 into 2, 6 and here you put 1. So 8k you are getting. So what you will do in these kind of problems, you will make a table. Here you will put the value of x and on the other side you will put the value of y. What you will do here, you will put the value of x. X can take value 0, 1, 2. So x can take value 0, 1, 2. And here you will put the values of y. Y can take value 1, 2, 3. Y can take value 1, 2 and 3. Now what this space will represent, let's make the table like this. Now what this space will represent? Probability of random variable x taking value 0 and random variable y taking value 1. What is given? Pxy is given. This is what they are saying, that this is PMF. Although we used to represent PMF in this manner, but the question paper setter can represent PMF in any manner, right? So this is the PMF that they are saying. So what this PMF represent? This PMF tells that random variable x take value small x and random variable y takes value small y, right? So probability of this taking value 0 and taking y taking value 1. So this is given as k into 2x plus 3y, k into 2x plus 3y. So x is 0, y is 1. So if you put x equals to 0 here, y equals to 1, what you are getting? 3k. x is 0, y is equals to 2, what you are getting? 6k. X is 0, y equals to 3, what you are getting? 9k. Now x is 1, y equals to 1, x is 1, y equals to 1, 5k. X is 1, y equals to 2, x is 1, y equals to 2, 8k. X is 1, y equals to 3, 11k. X equals to 2, y equals to 1, x equals to 2, y equals to 1, 4. X equals to 2, y equals to 1, 4 plus 3 is 7k. X equals to 2, y equals to 1. Yeah, x equals to 2, y equals to 2, 4 plus 6, 10k. And x equals to 2, y equals to 3. So 9 plus 3, 13k. Are you able to understand this point? The same question, the first question that we saw, this is the same question. The very first question that we saw. There this table was already given, now we are making this table. Now you know one thing, that x and y can take values between all these points only. That means, what do you understand? That 3k plus 6k plus 9k plus 5k plus 8k plus 11k plus 7k plus 10k and plus 13k would be equals to 1. Say yes or no? Because x can take 0 and y can take 1, or x can take 0, y can take 2, or x can take 0, y can take 3, or x can take 1, y can take 1, or x can take 1, y can take 2. So all these combined will be, all this addition will be equals to 1. All the probabilities I am taking into action. All the probabilities I am taking into action. So let's add them. 30, 9, 18, 30 plus 18 plus 19 and 19 plus 5, what that would be? 24. 24 plus 18, 72k. Okay, what it is coming out to be? 72k, and that is equals to 1. So value of k is coming out to be 1 by 72. Okay, let's check the calculation again. 0, 1, 3k, 6k, 9k, no issue. 1, 1, 5k, 1, 2, 6, 8k, 1, 3, 11k, 2, 1, 7k, 2, 2, 10k, 2, 3, 13k, and you add all of them, 18, 30, 18, 30, 48, 48, 11, 59, 59 plus 5, 64, 64 plus 8, 72k, k is equals to 1 by 72. So this is the answer of k is coming. Did they ask the value of k? No. Now they are asking probability of y equals to 1. So y can take value 1 when x is 0, x is 1, x is 2. So what do you think, what you need to do? Y should be equals to 1. That means you will add all of them. So probability of y equals to 1 would be 15k. That would be equals to 15 by 72. 5 by 24. Right? Probability of y equals to. So in the same manner you can find out everything, no? Y equals to 2. What that would be? 24k. 1 by 3. Let's just say I find for x equals to 1. And this would be capital X, not small x. X equals to 1. So 5k, 8k, 11k, 19, 24k. This is also coming out to be 24k. Right? X equals to 2 also you can find what will be the answer? 30k. That would come out to be 30k. So 30 divided by 72. Right? So these are the answer. Next, what they are asking? X should be greater than 2 given that y is less than 1. Probability of x should be greater than 2 given that y is less than 1. X greater than 2. X should take value greater than 2. x should take value greater than 2 given that y is less than 1. Y is less than 1. It is not even possible, right? Y cannot take value lesser than 1, no. Y can never take the value less than 1. So here let's change this equation. At least it will make some sense, okay? Y should be less than equals to 1. What does that mean? Probability of x taking greater than 2 intersection with y taking value lesser than equals to 1 divided by y taking value lesser than equals to 1. So y taking value lesser than equals to 1, that means y can take value 1 only. So this probability I need to write down. So probability of y taking value equals to 1 is 5 by 24, and y taking value lesser than 1 and x taking value greater than 2, that means x can take value 3 and y can take value 1. So only one condition will come, which is x can take value x greater than 2. अरे यार भाई क्या क्वेश्चन फ्रेम किया मैंने ये. This is also not possible, no. So here also equal sign, here also equal sign, okay. So x taking value greater than equals to 2, so x can take only one value which is 2, and y should take value lesser than equals to 1, that means y can take only one value which is 1. So this answer would be there 7k. So what that would be 7 by 24. ये क्या हो रहा है भाई? 7k, अच्छा 7 by 72. Let's write it down. This is 7k, right? You understood, right? X should be greater than equals to 2, that means x can take only value 2, and y should be less than equals to 1, that means y can take value only 1. So 2 and 1, that means 7k will be the answer, no. So answer will be 7k divided by y should be less than 1, that means y could be equals to 1 only. So what this would be? 15k. So answer is 7 by 15, right? X plus y should be greater than 3. What do you think? What will be the answer of this one? X equals to 1 and y equals to 3. X equals to 1 and y equals to 3. 11k will be the answer, right? X equals to 1 and y equals to 3. Y equals to 3. X equals to 1, y equals to 3. So what will be the answer? If you go here and come here, this will be the answer 11k, right? So answer will be 11k here. 11, what is the value of k? 70 by 2. 72. Value of k is 72. So let's solve this one. X plus y greater than 3. So probability of x plus y greater than 3. So here now you need to think that my x can take value 0, 1, 2 and y can take value 1, 2, 3. So now x plus y should be greater than 3. What does that mean? That means if x is 0, maximum y could be 3. Basically x plus y should be greater than 3. So what do you think, what all cases can come? X equals to 0, y equals to 1. Can this case come? No. X equals to 0, y equals to 2. Can this case come? No. X equals to 0, y equals to 3. Can this case come? No. Because x plus y should be greater than 3. So what all cases can come? Think about it. So which all cases will come? Now I will directly write it down. So the cases that will come will be x equals to 1 and y equals to 3, or x equals to 2 and y equals to 2, or x equals to 2 and y equals to 3. Only these cases will come, because 2 plus 3 5, 2 plus 2 4, and 2 plus 2 4, 2 plus 3 5, and 1 plus 3 4. That's it. These cases will come. 0 1 cannot come, 0 2 cannot come, 0 3 cannot come, 1 1 cannot come, 1 2 cannot come, 1 3 can come, 2 1 cannot come, 2 2 can come, 2 3 can come. So these cases can come. So 1 3, 1 3, 2 2, 2 2, and 2 3, 2 3. These cases can come. So what will be the answer of a probability of x plus y greater than 3? That would be 21 34k, 34 by 72. This will be the answer. Okay, this is the answer. 24 34, 34k, 34 by 72. Very easy question. You just need to make the table and your job is done. Just make the table and everything is done. Well and good. Let's go to the last question. But I think I need to take a break. You try it on your own. You should be able to do it. Very easily you should be able to do it. Try this question on your own. Joint PDF is given, right? You draw the diagram. X should be greater than 0, y should be greater than 0, x plus y should be less than equals to 2, and x plus y should be greater than equals to 1. You draw the diagram, you find the region of operation, and then you find the probability. Do it on your own. I need to take some break. I need to drink some water because it's been roughly around 55 minutes. And then we will end this lecture. Okay? Yeah. Thank you. Yeah, welcome back. So did you try this question? X should be greater than 0, y should be greater than 0, and x plus y should be less than equals to 2. So 3 conditions are given this time. What all 3 conditions are given? On random variable x and y, they will take the value in this manner. In which manner? That your x is greater than 0, y is also greater than 0, and x plus y should be less than 2. X plus y should be less than 2. So let's just say if this point is 2, this point will be 0. If this point is 0, this point will be 2. So this is the equation of x plus y equals to 2. So where will be x plus y less than 2? So if you put 0 comma 0 in this equation, if you put 0 comma 0, is it satisfied? Yes. That means this will be the region. And along with that, they are saying that greater than 0, x should be greater than 0 and y should be greater than 0. So what will be your region of operation? So till this point, you should be comfortable with the region of operation. This will be your region of operation. This is your region R. Right? So this I am calling as region R. So one thing you know that in this region R, if you take your fxy and calculate dx dy, that will come out to be equals to 1. Right? You can calculate this particular thing. In this region R, can you calculate fxy dx dy? Yes. How will you calculate? You will take the strip. Y will go from 0 to 2 minus x, and x will go from 0 to 2. And in that manner, you can calculate, right? Now, what you actually need to find? You need to find the probability of x plus y greater than 1, greater than equals to 1. What you need to find? You need to find probability of x plus y greater than equals to 1. That means again you need to take another region, x plus y greater than equals to 1. Which region it would be there? So this is the equation of x plus y equals to 1. This is the equation of x plus y equals to 1. And what you need to take? X plus y greater than equals to 1. So that would be here or here. Like if I put 0 comma 0 here, 0 plus 0, so 0 is greater than 1. Is it satisfied? No. That means what will be your region of operation? So basically I need to find the probability in this region. I need to find the probability in this region. This is what I need to find. So what I actually need to find? So total region I was calling as R. So I am calling this particular region as R dash. Okay, or yeah, R dash. I am calling this region as R dash. So what you need to find? You need to find this particular thing. R dash fxy xy dx dy. Have we seen this example before? Yes. Because here if I take the strip, it will be difficult for me. Because if I take the strip here, this example we have already seen in the last lecture. Right in the beginning we saw this example, right? If I take the strip vertically, so what will happen? If I take the strip vertically, what will happen is that I need to change the strip here. Here I need to change the strip, right? And what if I take the horizontal strip? Let's say if I take the horizontal strip. So in the horizontal strip also there will be problem. Why is that so? Because if this horizontal strip goes here, then the limit will change, you know. Like if I take the horizontal strip, that means in this strip what will be the value of x? So value of x will be from 1 minus y to 2 minus y. Here x will be going from 1 minus y to 2 minus y, right? And here your x will be going from x equals to 0 to 2 minus y. X equals to 0 to 2 minus y. So both in the horizontal strip there is a problem, in the vertical strip as well there is a problem. You will have to do the integration 2 times, which will take a lot of time. So in the strip there is a problem. But what do you know here? If I call the whole region as R, this region as R dash, so can I call this region as R double dash? So what do you know here is that your surface integration for the whole region is equals to surface integration for r dash plus surface integration for r double dash. Say yes or no. And you know that this will be equals to 1. And what you need to find? You need to find it for r dash. So what you can do is that 1 minus for r fxy x comma y dx dy, and that would be equals to, so this is r double dash. This r double dash is coming here because I know that finding r double dash is easy for me, right? Finding the surface integration for r double dash will be easy for me because here if I choose the strip, then what I will say? The limit of y is going from 0 to 1 minus x. The limit of y goes from 0 to 1 minus x. So it will be very easy for me to find out, right? But here, this particular thing would be difficult. So instead of calculating this particular thing, what I am calculating? This particular thing, and then I am subtracting it from 1, right? So this is the trick that we have played here. So what I need to do here? Here I have chosen the strip. Strip is going from y equals to 0 to y equals to 1 minus x. Y equals to 0 to y equals to 1 minus x. And x is going from 0 to 1 because this point will be 1 comma 0. So x is going from 0 to 1. X is going from 0 to 1. And what is your fxy dx dy? That is 3 by 2 xy dx dy. And that will be equals to your answer basically. That will be your answer. What your answer is saying, that this will be equals to probability of x plus y should be greater than equals to 1. So have I solved this integration somewhere? Surely I have solved. Where I have solved? In the beginning of the slide. You will see that this integration have been already solved by us. Where it have been already solved by us? I guess here, right? xy dx dy 0 to 1 minus x. So this integration have been already solved. It will give you value 1 by 24, right? So it will give you the value of 1 by 24 which have been already solved. So I can use this value here, right? Am I doing it correctly? Everything is correct here, no? So xy into dx dy from 0 to 1 minus x, 0 to 1. So this have been solved here. 2 by 3 is constant and it is giving me 1 by 24. Yeah. So I can go to this slide. So 3 by 2 is constant. So 0 to 1 minus x, 0 to 1. So this is giving me 1 by 24. Right? So it was giving you 1 by 24. So you can see that the answer would be 1 minus 1 by 16. So that would be equals to 15 by 16. So this will be the answer. That's it. This is the end of this lecture. Okay. So we have studied about two-dimensional random variable. It will again come back. In the 5th or 6th lecture, this two-dimensional random variable will again come back. And all these concepts will also again come back. But till this point, you have understood it in a very good manner. So quickly revise all the questions that we have done. Quickly solve all the questions that whatever that we have solved, solve all the questions on your own. Okay. Once you solve it, you will have a very good confidence in this particular topic, which is considered as one of the toughest topics of a complete communication system. That's why I wanted to deal it in the beginning, because usually this particular topic is dealt in the last, because it is tough, right? But we wanted to deliver the tougher things before in the starting only, so that you are at this time you are very enthusiastic, right? You are having the good enthusiasm for studying communication system. So at this time you can understand tougher things as well, right? So yeah, that's it. This is what we have understood. This is your two-dimensional random variable that we have understood. Next we need to study about statistical parameter of random variable that we are going to see in the next lecture. Okay, so we will talk about mean, mean square value, variance, standard deviation, nth order movement about origin, nth order joint movement about origin, nth order movement about mean, nth order joint movement about mean, correlation, covariance and correlation coefficient. Okay, so all these things we will talk in the next lecture. Yeah, thank you very much.